So what I will do is I will create another test class, another class. This is, I'll say main class, and take this main method here and finish it. So now I have two different classes. So I will just commenting this main method here. Okay, commenting this main method here. Okay, now this is a plain class. Static example is my plain class, which contains a few static and non-static variables and static and non-static methods. Now the main method is created in different class. Main method is created different class. Now I need to use this class. Now from the main class, I want to use static example class. So what are variables and methods they have created, I want to use in the main class. Okay, so how we can do this? So here I'll just copy the same stuff here and observe what will happen. So here, if we have the main method in the same class, we are able to call M1 method directly, right? So because, and also we are able to use this variable called A. Because main is also static, A as well as M1, these are also static. So we are able to directly access them. But when I try to write main method in the another main class, here it is starting giving some error. Okay, same thing, but it is giving some error here. Why it is giving error means, if you have the main method in the same class, right? So this main method will know this A and M1 is belongs to the same class, right? But when I create a main method outside of this class, this main class doesn't know about what is this A, what is this M1, from where it is coming from, right? So we have to specify the class name, from which class these variables and methods are coming from. So static example dot A, and here static example dot M1. So this is how we need to access. So if you want to access static variables and static methods outside of the class, we must specify the class name dot variable name or class name dot method name. But if you create main method within the same class, we don't require the class name. So directly we can call them. But outside of the class, if I want to call if I want to call static variables and static methods, we must use, okay, we must use class name dot variable name, class name dot method name. So this is how we need to use. Okay, so this is another important point you guys remember. And non-static anyway, fine. So non-static, we created anyway object of this class, and through object we are able to access. This is perfectly right. So only the thing is, if you want to access the static variables and static methods within the same class, we don't require to specify the class name dot variable name, class name dot method name. But if you want to access static variables and static methods outside of the class, we must specify the class name dot variable name, class name dot method name. So this is another thing you need to remember. Okay, so static variables and static method we can directly access using class name, but non-static stuff we should be able to access through object. Okay, so remember this very important topic. So we are going to use static keywords many number of places. So that is all about static one. Okay, so now we have understood. Let me just summarize this. So static methods can access static variables, static methods directly, and non-static variables also can access, but through object is also possible. So this is through object, through OBJ it is possible. But non-static methods able to access static variables, static methods, non-static variables and non-static methods directly. There is no restriction for them. Okay. So this is all about the static keyword. Now come to the last one, system.out.println. So now this is the right time to discuss about system.out.println. So far we are using this command every time. If you want to print something in my console window, I have to use system.out.println. But what is system, what is out, what is this println? So that we need to understand. And interview point of view also, this is very important. So what is system.out.println? So people will simply say this is just like a output statement. If you want to print some output, we can use system.out.println. So that's the only answer people will say, but they don't explain what is exactly system, what is exactly out and println. Okay, so I'll give you the context what exactly it is. And before understanding this, I will just give you some example, and based on that example, we can just simulate this. So let us say I have one class called as a test. I have one class called as a test. Okay. So in this class, I have a variable of type is string. So string string s is a variable, and the type of this variable is static. This is a static variable. So the variable is a static variable, and the data type of s is a string, and which is also contains some value. Let us say welcome. It contains some value. Now I want to access this variable outside of the class, and also I need to find out the length of this particular value, length of the string. So because s is a string, so it contains some value, I want to find out length of a string. The first thing is I want to access this variable outside of the class. Second thing is I need to find out the length of this particular string. Okay, so how to access this variable outside of the class? How to access this variable now? This is a static variable, right? So static variable can access directly using class name. So what is a class here? Test is a class. Dot s is a variable name. Test dot s is a variable name. Now s contains some value. So I want to find out the length of this particular string. So what is our methods we have? Length string method, length method we have. So we can directly use dot length, length, length. So this is a complete statement. So in this statement, test is a class, s is a static variable of type is a string, length is a method, string method. Because s is a string type of variable, we can use all string methods. Not only length, you can use all string related methods, right? So this will give you complete length of a string. So test is a class, s is a static variable of string type, length is a method. So now we'll simulate the same thing for this one. So here in Java, we have a system class. In Java, we have a predefined class called as a system class. So in system class, we have a variable called as a out. And what is the type of this variable is print stream type. Print stream type of variable. So here, this variable is a string type. Similarly, in Java, there is another type called a print stream type. So out is a print stream type, and this is also a static variable. This is also static variable, but it doesn't have any value. But here s contains some value, but here out doesn't have any value. So in Java, system is a predefined class which contains a variable called as out, that is a print stream type and static variable. Okay. Now I want to access this out variable outside of this class. So how we can access this out variable outside of this class? Because out is a static variable, I can access directly specifying the class name. So what is the class name here? System is a class name. Dot out is a static variable. Out is a static variable. And what are all different methods are available which are belongs to print stream is there are two methods are available. One is print and the other one is print ln. So here print ln is a method which is belongs to print stream class. Similarly here length is belongs to string class. Similarly print ln, print, these two methods are belongs to print stream class. Now here length method is return the length of characters, length of a string. But here print ln method will print something whatever we pass as a parameter. So here, so let us say welcome. So whenever whatever we pass in the double quotations, this message will be printed in the console window. That is the behavior of println method. But here the length method behavior is it will calculate the how many characters we have in the string. That is the output it will return. But what the output it will return, println statement which will return the same message as an output. Whatever message we have put in the double quotations, the same message will be printed in the console window. So that is the behavior of println statement. And you can also use a print statement, print or println. So these two methods are belongs to print stream class. So now we will see the overall statement system.out.println. System is a class name, out is a static variable of a print stream type, print is a method. Print and println are methods which are belongs to print stream class. So this is a history of system.out.println. So this is a story about system.out.println. Okay, so you have to explain this with this some small example. So here system is a class name, out is a static variable of print stream class, and print is a method which is belongs to print stream class. Okay, so that's how we need to explain system.out.println command. So if you remember this example, you can just simulate the same thing here. Here also test is a class, s is a variable of static type, and length is a method. Okay, so guys, are you clear? So this one, what is system.out.println? So this is another important interview question. Okay, what is system.out.println in Java? So if you understand what is static, then you will know about system.out.println. So because here this is belongs to static keyword. All right. So we have discussed today about this keyword, call by value, call by reference, static keyword, and finally system.out.println. In the next session, I will discuss about few more important topics called inheritance, interfaces, and so on. Okay, so for today, just practice these items and come to assignment part. And these are the assignments. So the first one, create a class calculation with the following methods. So create one class called as a calculate. I think I have given this yesterday itself. Okay, so this is basically related to method overloading. Okay, method overload. I think this is an assignment I already given yesterday. Okay, so please try this one. Same assignment. Okay, so the question is println and print have a system defined logic. Yes, exactly. You're right. So normally method is nothing but it contains some logic, right? So here these are all user defined methods. So M1, M2, M3, these are all user defined method we created. Similarly, print and println also created by Java itself. Okay, so whenever we call print and println method, the internal logic will be executed. Even in the length method also, when I call the length method, what it is doing internally is it is performing some action internally. It is executing some logic which will find the length of this string. Similarly, when I say print or println, internally it is executing some logic, and that logic is responsible for printing the statements in the console window. Okay. So that's all about today's session, guys. So please practice class examples today. And I'm not giving any new assignments. So please practice all these things. Very, very important, especially static keyword and this keyword. So these are very, very important topics for today. And rest of the topics we'll discuss tomorrow. All right, so let's start today's session. So today we are going to discuss about a few important topics: Java inheritance and method overriding and super and final keywords. So first let us start with the Java inheritance. So what is Java inheritance? So this is one of the important feature in object-oriented programming. So by using this particular feature, we can use one class methods and variables in another class. So for example, we have two different classes, and one class we will define all the variables and methods, and I will create another class, and in the new class we can use all the variables and method from the previous class. So for example, I can say parent and child class. So I have a class called A, and this contains a few variables, let's say A, comma, B, comma, C, and it is also contains a few number of methods called M1, M2, and M3, and so on. So this is one class. Suppose there is another class called as a B, and this is also contains some variables, let's say X, comma, Y, and then M5 and M6, and so on. It contains its own things. So now what I want to do is I want to create certain logic, and which is already there in the class A. So a class A methods already implemented those logics. So instead of creating the new logic again in the B class, I will just use this class in B. So I just extend everything from A to B. That means I'll acquire everything from A to B. So now what happens is A becomes a parent class of B. A becomes a parent class of B class. Now B is called as a child class. So here A is called as a parent class, or it is also called as a base class, and also it is called as a super class. And here B is called as a child class, or called as a derived class, or we can call as a subclass. So one class is acquired all the properties and behavior, everything from one another class. This is called as the inheritance concept. So what is the use of this inheritance is reusability. So once we created these variables and methods, we can use these variables and methods any number of times in some other classes. And for the same class, we can create any number of classes. Suppose we can create any number of new classes and we can use these variables and methods in those classes. All these classes called as the child classes, and A is called as a parent class. This is just like an inheritance. Means whatever property we have in the parent, so child can acquire its own property from the parents automatically, right? And child can have its own property. The same concept is applied here. So inheritance means acquiring all the properties from parent to child class. This is basically called as inheritance concept. And to extend everything from, or to acquire everything from parent class to child class, we use one keyword called as extends. Extends we have to use. This is a keyword. Okay, so in Java, we have multiple types of inheritances we have. So we'll discuss them first of all. So let me just write a definition. So inheritance is acquiring all the properties, means attributes, and behavior in these methods from one class to another class is called as a inheritance. And there are 5 types of inheritances we have: single inheritance, multi-level, hierarchical, multiple, and hybrid. These are the 5 types of inheritances. So what are those 5 types of inheritances? So single inheritance, multi-level, hierarchical, multiple, and hybrid. So let me just open whiteboard. So first let us see what are those 5 types of inheritances, and then we'll see how to implement those inheritances types. So the first type is single inheritance. So single inheritance means we will have only one parent, have only one child class. One parent class and one child class. A is a parent, B is a child class. This is called as a single inheritance. Single inheritance. And multi-level inheritance means this is called single. And multi-level inheritance. Multi-level means we have multiple levels, like one parent and have one more child class, and B is also having one more child class. So like this, we can create any number of levels. So A to B, B to C. For C, B is a parent class. For B, A is a parent class. So B is acquired everything from A. So whatever A contains, B also contains them. And B is acquired into C. So C contains everything from B as well as A. So this is called as multi-level inheritance. Multi-level inheritance. This is the second type. The third type is hierarchical inheritance. Hierarchical inheritance means one parent have multiple child classes. One parent can have multiple child classes. So A is a one parent class, B and C are the 2 child different classes, and you can create any number of child classes. This is called as a, this is a third type, called as a hierarchical inheritance. This is called hierarchical inheritance. And there is one more inheritance called multiple inheritance. Means one child class can have multiple parents. So for example, A and B. So these are the 2 parents having one child class. So this is called as a multiple inheritance. This is the fourth type of inheritance, multiple inheritance. And one child class can have multiple parents. And the last one we have hybrid inheritance. It is a combination of hierarchy plus multiple. So here we have 2 child classes. So till here this is hierarchical inheritance. One parent can have 2 child classes, and in the bottom there is one more class. So in the upper portion this is satisfying hierarchical inheritance. In the lower portion this is a multiple inheritance. So combinedly we can call it as a hierarchical inheritance. So hybrid inheritance. This is called as a hybrid inheritance. So these are the 5 types of inheritances. So in 5 types of inheritances, the first one, second, and 3, single inheritance, multi-level, hierarchical. These 3 inheritances we can achieve using class concept. So normally we know what is the class and object, right? So using class, we can achieve single, multi-level and hierarchical inheritance. But we cannot achieve multiple and hybrid inheritance. So class not supports multiple and hybrid inheritance. So to achieve multiple and hybrid inheritance, we have another type of concept called interface. So interface is also almost like a class, but it is having different kinds of properties. So interface is an alternative of the class, but is having a different kinds of properties. So using interface, we can achieve multiple and hybrid inheritances. Okay, using interface, we can achieve multiple and hybrid inheritance. Because if I use a class cannot extend multiple parent classes. So that is a problem in the class. So one class cannot extend multiple parents. So here it will fail. If multiple inheritance itself is not satisfied, hybrid inheritance also contains a multiple internal array. So it is also not satisfied. So these two we can achieve by using interface concept. And first three types of inheritances we can achieve using class concept. And today we'll focus on first three types of inheritances. And in the tomorrow session, I'll show you what is interface, how to declare interface, and how to achieve these two inheritance concepts using interface concept. Okay. So today we'll focus on first three types of inheritances: single, multi-level, and hierarchical. Now, let me show you one example. So first, let us start with the practical example. So first, single inheritance, multi-level, hierarchical. So first, we'll see these three types of inheritances. So this is our project, and today is day 8. I'm creating a new package, day 8, finish. So I'm just creating a new class, and my class name is inheritance or inheritance types demo. Inheritance types demo. Take this main method, then finish it. Okay, so this is one class. So here public class inheritance demos, right? This is one class. Inheritance demo is a one class. So here I'll keep this class one side, and now here I'll create multiple classes, because if you want to use inheritance concept, at least we should have two classes. Okay, one class we cannot do anything. So at least we should have two classes. So then we can define one class as a parent, the other class is a child. So let us have inheritance demo types demo. This is the actual class, and here I will create one class, class A, and this class contains, I'll define one variable called A. So this is one variable called A, and along with this variable I will also create one method. Let's say void display. This is a method. So inside this method I will print that value of A. So here system dot out dot println, just print the value of it. So this is a parent class. So this is just a normal class. Class A, which contains a variable called A and is also trying to display the value of A in the using display method. Okay. Now I'll create another class, that is class B. This is a new class, and class B extends. So class B is also contains integer B. So integer B. This is a variable, and I will also create one method called void print. Okay, so this is the method, and inside this method I will print the value of B. So I will print the value of B. So now I have A and I have B class. So two classes I have. So whatever I have already created in class A, I want to use it in the class B. So that means B should acquire everything from class A. So what I can do is I can use here extends A. So when I say extends A, then A becomes a parent class. A becomes a parent class and B becomes a child class. Here B is child class. B is a child class. So now B acquired everything from class A, right? So when I create print is also, print is system defined function. When it will become system defined function, if I use system.out.print, then it is a system defined function. Okay, but here this is just a user defined function. So user defined method. Okay, so just it is a normal print method which is belongs to class B. But here this println and print, this is belongs to system.out. Okay, that is a different. This is a system defined function, but this is a user defined function. So we can create. So here system.out.println, I'm just printing the value of B here using print function. So currently I have two classes, and class A is a parent class, class B becomes a child class. So when I create an object for class A, I can access variable A and display method. And when I create an object for class B, I can access B and print method along with this A variable and display method. Why? Because this is already extended everything from class A. Now B is also contains A and display method. So when I say, as soon as I say extends A, B contains everything from class A. So when I create an object for class B, I can also access everything from class A, because A becomes a parent class of class B. So B contains everything from class A. So that's the logic here. So now come to the main class. So in this main class, objects and everything should be created in the main class and main method itself. So come to the main class and main method. Here, if I create an object for class A, so let me just create an object for class A. Obj is equal to new A. So now I created an object for class A. Now when I say here Obj dot, okay, now you can see it is displaying A and also display method. So these two are visible. So I can access the value of A and display method. So I'll access A here. So Obj dot A is equal to, I'll put some value here, and Obj dot, then I can call display method. So when I create an object for class A, I can access only this particular variable and only this particular method. So when I run this, it will print the output here 100. So 100 we assign to A, so 100 is printed using display method. Now what I will do is, I will just create object for class B. So here Obj is equal to new B. Okay, so Obj is equal to new B. So now I have created object of class B. So by using this object, I can access everything from B as well as A. So when I say Obj dot, now we can see it is visible. All the variables and methods are visible from B as well as A. So A and B, and here display method and here print method. So everything is populated here. So when I create an object for class B, I can access everything from B and also A as well. So Obj dot A is equal to, and here I'll put 10 Obj dot B also I'm able to access. B is equal to, I'll say 20, and Obj dot, first I will call display method, then Obj dot print method. Okay, so now when I create an object for class B, I'm able to access everything from class A and also class B as well as class A. So this is called as single inheritance. So when I run this code, so this 100 is printed by this one display method, and 20 and 10 and 20 is printed by display method and print method. So this is called as single inheritance. So we have one parent and one child class. Okay, this is external class. Okay, inheritance types demo. This is a completely different class, and where we have created objects of the classes, and we can use. If you want to separate this main class, you can create another class file, and you can write this code separately instead of putting in the same class. Okay, so this is called as single inheritance. It is called as a single inheritance. Means we have only one parent and one child class. And the next one is a multi-level inheritance. So multi-level inheritance means we have multiple levels like A to B and B to C. Here we have a multiple levels. We can create any number of levels, and it includes a single inheritance. Again, if you see here, A to B is a single inheritance, B to C is also single inheritance, but it contains multiple single inheritances. So we can create any number of child classes like this. So what I will do is, in the same example, so I'll create one more class here. Along with the A and B, I will create one more class called as a C and extends B. Extends B. So now here C is a child class of B, and for C, B is a parent class. So here C is child class of B, but here B is a child class of A. Okay, so when I create a child class C, it is acquired everything from B. That means if I create an object for C, I can access everything from C, B as well as A. But why we are able to access from A also? Because whenever I extend as B, right? So B is already having everything from A. So because B is already extended everything from A. So that means B contains A variable, B variable, display and print everything. When I extend B into C, now C contains everything from B as well as A. So this is called grand child class. Okay. So now I'll implement something in the C. So here I'll create another variable called integer C. And to print the value of C, I will create one more method. Let's say void show. And inside this method, I will just write. So we have display method here, print method here, and here as a show method. So here I can say system.out.println. I just print the value of C here. Okay, this is a C method, C class. So now I create an object of C here. C obj is equal to new C. So now by using C object, I can access everything from A as well as B. So C obj dot, when I say C obj dot, now you can see all three variables are visible here. Display method is visible and print and show. So these two methods are also visible. So now I can access all the variables. Let's say COBJ is equal to 15. Some value I have assigned. COBJ dot D is equal to 25, and COBJ dot C is equal to 35. So some values I have given. Now I'll call all the three methods. COBJ dot first display method. You can call any order, or similarly you can also assign the variables in any order. Order is not much important here. So COBJ dot next one is print method, and then COBJ dot show method. Okay, so now when I create an object of C, I can access everything from A, B as well as grandparent A. So let's run this as Java application. So now we got, these are the three outputs we are getting from C object. Okay. So this is how we need to implement single inheritance and multi-level inheritance. Multi-level means we can have multiple levels. So multiple parents and multiple child classes. So this is called multi-level inheritance. So there is another type of inheritance called as a hierarchical inheritance. So we can also achieve hierarchical inheritance. So in hierarchical inheritance, one parent can have multiple child classes. So if we observe here one more time, B and C are derived from the same class. B and C are derived from the same class, but B and C are independent. So they are nowhere related. B and C is nowhere related. Okay, so when I create an object of B, I can access everything from B as well as A. Similarly, when I create an object of C, I can access everything from C and as well as A. But B and C are completely different. Okay, so let us implement this hierarchical inheritance in another example. So let me create another class. So here I will name it as hierarchical inheritance demo, and take this main method, then finish it. Okay, so here keep this class one side. I'll create multiple classes here. So in the hierarchical inheritance, one parent can have multiple child classes. So here I will create one parent class. I'll name it as a parent. I'll give the direct name called as a parent. This is a parent class. And in the parent class, I'll create again a variable called integer A and void display. So inside this method, I will just print that value of A. System dot out dot println. I can just print the value of A. Okay, so this is a parent class which contains a variable and which contains a method. Now for this one parent class, I can create multiple child classes. Okay, so is the access of class variables called by value? Yes, you can access, still we can access the methods, we can pass the parameters, these methods, everything is same. Okay, so whatever topics we have discussed in the previous sessions, we can pass the parameters, we can do overloading. Okay, and today I'm going to also show you one more concept called overriding also, which is especially applicable in only inheritance. Okay, so everything is possible. So call by value is also possible. We can pass parameters to this method also. Okay, so I'll show you that example in this particular example. Okay, I'll show you how we can pass the parameters using call by value. So I have one variable called as A, and I have a method called as a display method. So this is one parent. So now I'll create another class called as a, so as I said, hierarchical inheritance, we can have multiple child classes for one parent class. So here I'll say class and child one class I created, child one. So first child of the parent. So here this child one should extend everything from parent. Okay. Now child one can have its own stuff. Let's say here I'll create some other variable. Let's say integer x, and here I'll just called void show. So void show. So this is another child one. So here I'll print that value of x. So let's print system dot out dot println. Just say x here. All right. So now I'll create one more child class for the same parent, class child2, and which is extends same parent. So now here and here we are using same parent class. So these are the two child classes of the same parent, and child1 and child2 is nowhere related, but these two classes are derived from the same class. So child2 contains its own stuff. It's a, here I'll define integer y, and I'll define a method called void show is already created, right? So it is also contains a show method, and here I will print this particular thing. So I'll just print that value of 1. Okay, so this is another class. So now child1 is derived from the parent, and child2 is also derived from the same parent class. So these two are the child classes of a single parent class. So this is called as hierarchical inheritance. One parent can have multiple child classes. Now come to the main class. So in this main class, when I create an object for child1, I can access everything from child1 as well as parent. And when I create an object for child2, I can access everything from child2 as well as parent class. So when I say child1 c1 is equal to new child1. Okay, so I just created an object for child1, and c1 dot. So when I say c1, now you can see a and x is visible. So a is from parent class, x is from child1 class. So I can access this a, and I'll put some number here, and c1 dot I can access display method. And similarly, child2 also I will create one more object. C2 is equal to new child2. And when I say C2 is object, then C2 dot, now you can see it is visible A as well as Y. So A is from parent class, Y is from child2 class. So here it is visible. So here I'll say A value is 200, and the C1 dot, C2 dot. So the method is display method. I think something went wrong. So parent is having display method, child1 is having show method, child2 is having also show method. So here A is equal to 100. So C1 object I created, C1 dot A. So A is basically belongs to parent class. Similarly, C1 dot I'm able to access also X, right? So X also I can assign some value here. And then I can call display method, and I can also call show method from C1 class. Show method from C1 class. Now I created C2 class, C2 object for the child 2 class, and A is equal to 200 I put, and C2 dot Y also I'm able to access. I'll say 300, and let's say this is 300, this is 400. So now we can print those values. C2 dot first method is display, which is coming from parent class. C2 dot show. So this show is belongs to C2 class. So show method is created in two classes. Child 1 is also having show. Child 2 is also having show method. You can also give different names. Nothing will happen. So now execute this. So the first two values are coming from C1 object, and the last two values are coming from C2 object. These two methods are printed. Okay. So this is how we can implement hierarchical inheritance. So for example, instead of hard coding the values here, so instead of putting this variable, I want to pass the values to these methods. So how we can pass? So for now, I'm just comment these variables in both three classes. So instead of this variables, I will take some parameters. Let's say integer. Okay, some variables. Let's say some variable called var. And every method, I'm expecting some parameter here, var. Okay, or we can say integer a itself here. So I'm taking a variable called a value, I'm printing it here. And here I'm taking x and printing it here. And here I'm taking y and printing it here. Okay, so this is how we get to. So this is integer type and this is integer type. So this time what I'm doing here is I'm passing the variables. So I'm passing the variables. So instead of creating a variable, I'm getting the values into method and I'm printing the same value here. Again, this method is getting some value from outside and printing the same value here. And here also it is doing the same thing. Now, so we no need to assign any value here because we are not defined any variables, right? So we no need to assign any value. So let me just comment them. Now, the change here is whenever we call the display method, so here display method is expecting some parameter, right? A is a parameter it is expecting. So we have to pass that parameter value. So let's say I will pass 100 here and here I will pass 200 here. So now we need to pass. So let me just execute only these two. So C1 dot display method, C1 dot show method. When you see here, C1 contains everything from parent class also, display method and show method. So both methods require a parameter. So I'm passing some parameter here. So when I run this, it will print the same values of 100 and 200. Okay, so we can pass these values to these methods instead of creating the variables. And here also, when I create a child class object C1, it is acquired everything from parent class, that is called display method, and also show method. But here we don't have any concept of variables because we haven't defined any variables. Just we have commented this. Okay. If you create a variable, okay, then you no need to pass anything here. Just directly add the value to that variable using object and then call the method directly without passing any parameter. And if you want to pass a parameter, then you don't require to assign a value here. Okay. And similarly for C2 object also, I'll pass some value here. C2 dot display of let's say 10 and C2 dot display of show is called 15. Okay. Now run this. So it will also give the same output. So 10 and 15 is also printed. So this is how we can also pass the parameters. So passing parameters is the same concept even in the inheritance. Okay. You can pass multiple parameters and multiple data type of variables. You can pass anything. So this is called as hierarchical inheritance. So far we discussed about three types of inheritances: single inheritance, multiple inheritance, hierarchical inheritance. So these three types of inheritances supported by class concept, but a class cannot support multiple and hybrid. So why? Because if you want to write multiple inheritance, we have to write a statement like this, right? So C class extends A and B. So we have to write two classes here. So this is not possible using class. So we can create only one class at a time here. We cannot define multiple classes. So that's the reason Multiple and hybrid inheritances not supported by using class concept. So it is possible using interface concept. Okay, so the interface concept I will discuss in the tomorrow session, and today we are going to discuss a few more topics which are again related to inheritance. Like the very important topic is method overriding and super keyword, final keyword. So these things we can use only within inheritance. Okay, so let us discuss one more topic in inheritance. So we have discussed about Java inheritance and different types of inheritances, and first three inheritance types we have implemented. So multiple and hybrid inheritances we will see tomorrow session by using interface concept. So before implementing these two, we need to understand what is interface, how to create interface, how to use interface, all these things. So I'll just skip that particular concept to the next session, and let us continue with the method overriding concept. Method overriding. So this is another very important topic. So in the previous sessions, we have seen method overloading concept. Method overloading. So in interview perspective, these are very important questions. What is difference between method overloading, method overriding? So people will confuse, a lot of confusion is here. Method overloading, method overriding. So I'll tell you what are the differences between method overloading and method overriding. So please focus on this. So method overriding means, for example, I have created one class. So let us say I have a class. So I have a class called as A. So here I created a method called M1. Okay, M1 method I created with some parameters and some body I have created here. This is a method which is coming from class A. Now I created one child class of B, sorry, of A. So I created one more child class B, which is derived from the class A. So now in the B class is acquired everything from A, right? So now M1 is also belongs to class B. M1 method is also belongs to class B. Now in the class B, I want to recreate this method. So I don't like this implementation in the class A. Now what I want to do is I want to re-implement the same method in the class B. So here I will write the same method again. Okay, but I will change this body. I will change this body of this method. Okay, that means I will override this existing method with the new body in the child class. So this concept is called overriding concept. So overriding means here we should not change the definition of the method. That is very important point. We should not change the definition. What is the definition? Return type of the method, name of the method, number of parameters, data type parameters, order of parameters. So this is called as a definition. So we should not change any definition in the child class. Here if I say void, and here also it should be void. Here if you say method name is M1, here also it should be M1. Here it will take two parameter, here also it should take two parameters, and including parameter names also should be same, and data type of those parameters also should be same. So definition we should not change, but we can change only the body of this method. This is a concept of overriding. This is a concept of overriding. For example, if I change the definition, what will happen? If I change the definition of this method in the child class, that method will be treated as a different method. That method is treated as a different method. Now M1 from A is different, M1 from B is different. Okay, and this is again overloading concept. So in overloading, what we have done, we have created the method name is same, but we have changed the definition there. So first method is taking two parameters, the next method is taking three parameters. Or if it is the same parameters, data type we have changed. That means in overloading, we have to change the definition, but in overriding, we should not change the definition. We have to change only the body of the method. So that's the basic difference between method overloading, method overriding. One more difference is, in method overloading, we can have single class. Okay, we don't require multiple classes. Within the single class itself, we can create multiple methods with the same name, but we can change the definition. That is overloading. But when you come to the overriding, in overriding, we must have at least two classes. So in overriding, we must have two classes. So here the same method If I create again in the same class, it will say duplication. Okay, same definition. If I create one more time, it will say duplication. So in single class, overriding is not possible. And in the child class, we have to override that particular method. So overriding is possible only with inheritance concept. So without inheritance, overriding is not possible, but overloading is possible. Okay, so that is a second difference. So these are the two important differences we need to understand. The first difference is in overloading, we must change the definition of the method. In overriding, we should not change the definition of the method. In overloading, we can have only single class. We don't need to have multiple classes. But in overriding, we must have at least two classes. At least two classes. So in inheritance, overloading is also possible, overriding is also possible. But without inheritance, if you have a single class, here only overloading is possible, but overriding is not possible. If I have two classes, overloading is possible, overriding is also possible. How it is possible? Overriding means the same definition. Again, we will create another method in the B class with the same definition, and I will change that body. Okay, that's called overriding. But how overloading is possible? Means I will just use the same name of the method, but I will change the parameters and data type of parameters. Then it will be treated as a different method. So now B contains a one method from parent class, M1 method with one definition, and M1 method with another definition. So currently B contains two different methods. So that is overloading concept. So these are the two important things we need to remember. Okay, very, very important. So here I will just write a few important points about method overriding. So rewrite the methods in the child classes. Rewriting the methods in the child classes is called method overriding. Method definition should be the same and body should be the change. So these are the rules we have to follow when you do overriding concept. Method definition should be the same, body should be changed. Now I have just compared these two things here. In overloading, within a single class and multiple classes, in both the places we can do overloading. And here definition we have to change. But in comes under the overriding concept, only inheritance is possible. That means we should have at least two classes. And definition should not be changed. Only body can be changed. So that's the basic differences between method overloading, method overriding. Okay, so where we have to use a method overriding concept. So I'll show you with a real-time example where we can use this method overriding concept. So basically the concept of overriding is whatever method we created already in the parent class, I will just change that method I will recreate the same method again in the child class. So that is the concept of overriding. All right. Now let us try to implement this. Let's go to Eclipse. Now here I'll create another example to implement method overriding. So before implementing this method overriding, I'll show you one example here. Okay. So in this particular example, this is actual real scenario where we can use method overriding concept. Why we have to override all the methods every time means this is a scenario. So let us say I have a bank class. This bank is a parent class. This bank is a parent class and which contains a method called get rate of interest. Get rate of interest. So I have created one method in the bank class. Now for the same bank class, I have multiple child classes. So this is basically hierarchical inheritance, but we can still use any kind of other inheritances. So here for the bank class, I have three different child classes. So SBI, ICICI, and Axis. These three are the three different banks I have created for the same parent class. Because every bank is having some rate of interest. But the value can be changed. The rate of interest will be changed from one bank to another bank. But every bank should have some rate of interest. So what I will do here is I will just create one parent class called as a bank, which contains a rate of interest is a method. I'll create three different child classes of the same parent class. So when I create a child classes of the parent class, it will also acquire everything from the parent class. Now SBI is acquired everything from parent class, so it is also contains a get rate of interest. So here the body should be changed, because the bank class rate of interest will be different, but in the child class, as per this bank, rate of interest can be different. So in that context, I will change the body of this method here. Similarly, the same method is again recreated in another class and different classes. So that why we need to recreate, because that rate of interest value can be changed from one bank to another bank. So that I can just acquire the parent class, everything from parent class, then I can override those methods. Okay, this is a real scenario. So let us implement this. So I'll create another example class and I will name it as a method overriding. So let me just close this. Okay, so now here I'll give some name to this. Okay, so I'll just give some name to this class called method overriding demo. Take this main method, then finish it. Okay, so now I'll create a same thing I'm going to implement here. First thing is a blank class. So let's create one class called as a bank. So as this is a parent class, so here I will create one method. I'll create one method called as rate of interest. So it will return a double value. Double means a decimal number. So rate of interest value normally in the double, right? So decimal number. So I just say double here. So rate of interest, and it is returning 0. For now, it is not returning anything. It is returning some 0 value. So in the parent class, rate of interest method is returning 0. Now I'll create one child class of the same bank as class SBI. This extends from bank class. So SBI is a class which is extended from bank. Now bank is a parent class, SBI is a child class. Now what I will do is I will recreate the same method in the child class. Same method. But what is the rule here? If you want to, why we need to do overriding? If you want to change the body, we have to do overriding. Unnecessarily, why we need to have the same method again here? We don't require, right? So because SBI is anyway contains this method. Why again we have to create this method? If the body is same, we don't need to create anything else. If the body, if you want to change, then you have to recreate this method. Otherwise, not at all required. So here, when I create this method again, so that means I should change this body. Okay, then only there is a use. So here I will just return 10.5 is an interest. As per this SBI bank, my interest rate is 10.5. Okay, now I have changed this method. So this is overridden method. So whatever method we created in the parent class, I have override that particular method. Now I'll create one more child class. Let's say, so here ICICI. So this is another bank, and which is extends same parent class. Which is also extends the same parent class. Now in the parent class, it is returning 0, but here I will change that body. So here, as per this particular bank, rate of interest will be different. Let's say 12.5. So this is the rate of interest. So you can create any number of classes like this, and those classes are extend from the same class, and you can change this method. And if you have any parameters to this method, you must specify those parameters also. Very, very important. Okay. Because we should not change the definition of the method. We should change only the body of the method. That's a more important point here. So now I have just created two different classes for the same parent class, and I have override those methods in two different classes, two different child classes. Now come to the main class. So in the main class, main method. So first I will create an object of SBI. So SBI is my class, and here I'll say SBI obj, SBI class object, SBI obj is equal to new SBI. So now I just created an object for SBI. So now when I call SBI obj dot rate of interest, so this method is returning something, right? So we can print that value here, system dot out dot println. I can print the value here. Okay, so now which method will be called? So when I call this rate of interest method from SBI object, right? So SBI object I created and called rate of interest method. So whichever method is newly created, so SBI is already extended from bank. So the method is overridden here. So already method is modified here. So whichever the modified method we created newly, so that method will be executes. So when I create an object of SBI Bank, the latest method will be executes. So when I run this, it will give you 10.5. Okay. Similarly, I can create an object for another class. So this is ICICI. And let's say this is ICICI object dot rate of interest. So now when I call this rate of interest method from this particular object, then this should return 12.5. Run this as a Java application. Now it is written 12.5. So the same method we have in the parent, but according to our requirement, we can just override the same method in the child classes. Okay, so this is called as method overriding concept. In method overriding, we must change the definition. We should not change the definition. We should change only the body of the method. And this is very important concept. Again, it will repeat in when you are learning Selenium concepts. Okay, so this is a topic again I'll reuse in future sessions. So this is called as overriding concept. Overriding is possible only within the inheritance. At least we should have two classes. One is parent and one is child class. Okay, so this is all about overriding in inheritance. Overriding in inheritance. So we can override the methods in the child classes. So now we'll move on to the next one, super keyword and the final keywords. Super and final keywords. So these two keywords we can use only within inheritance. Okay. So let us see where we have to use super keyword, final keyword, and why we have to use them. So first let us see super keyword. The simple concept, okay, super keyword. So in the last session, I talked about static keyword, right? So this is super keyword. So this is a we can use only within inheritance. So super keyword can be used in two different ways. One is, here I'll write, super keyword can be used to refer immediate parent class instance variable. Super keyword can be used to invoke immediate parent class method. So to invoke immediate parent class variable, to invoke immediate parent class method. So what is this we need to understand? Immediate parent class instance variable, immediate parent class method. So immediate parent class, what is immediate parent class? Means I have a class called A and a B and a C. So I have derived like this. So A is extended into B, B is extended into A. For C class, A, B is an immediate parent class. For C, A is also parent class. So for C, there are two parents. B is a one parent, A is a grandparent. There are two parents are there. But what is immediate parent class? Means B is an immediate parent class of C class. Okay. Now the next thing is, what is instance variable? Instance variable means the variables which are created inside the classes are called instance variables. Okay. So the super keyword can be used to refer immediate parent class instance variable, and also can be used to invoke immediate parent class method. So these are the two important usages of super keyword. So let us understand these two with some examples. So here what I will do is I will just create a class, a new class. My class name is animal. Okay, my class name is animal. So I don't take any main method here, just it is a simple plain class. So in this animal class, okay, in this animal class, I'll create a variable. I will create a variable. So what is that variable is string color is equal to, let's say white. So white. So this is a variable I created inside the class. So string color is equal to white. Now this is representing some property of the animal. And eating. So I will just create one more method called as a eating. This is representing some behavior of the animal. So in the eating method, I will write a message called system.out.println. I can just print something. So let's say eating. Okay, so this is my animal class. So animal is my class which contains simple a variable and a method. Now I'll create another class here called as a dog. Okay, and this dog class extends everything from animal. Extends everything from animal class. Now observe this. So when I say extends here, so the dog is a class which is extend everything animal means it is extended everything means all the variables and method which are belongs to class animal is also belongs to class dog, right? So here everything. Now what I will do is I will override the value of color. So I will redefine this variable again here, and this time I will change this value. So when you come to the overriding concept, not only methods, we can also override the variables. Okay, so in the previous, in the parent class, the value of the variable is white. But in the child class, I have changed the value of the variable is black. The value of the variable is black. This is called also, it is also overriding. So not only methods, we can also override variables. So as soon as I have changed with a new variable, so now the current value of the color is black. The current value of the color is black. This is a new value. Okay, so this is a one. So now I have just created one variable, and here I have created one eating is a one method, and here I will also create same method you can create, or you can just leave as it is. All right. So now what I want to do here is I'll just create one more class. Observe this. This is more important. And I can create one more method here, display method. Let's say void. Okay, so display method. So just I want to see the color value, right? So to print the color, I can just create one method called display here. And here I'll say system.out.println. The value of color I will print here. Okay, that's it. So this is a child class I created called dog, which contains this variable, and eating method anyway will get it here, but additionally I created a new method called as a display method, and when I call the display method it will print the color value. Okay, this is a condition. Now let's go and create another class. So here I will just specify test to super. So this is another main class. Take this main method inside this class. Okay, now observe this carefully. So this is the first class animal, which is extended by dog class. Okay, and also I have override that value of this variable, and here I'm printing the value of color. Now come to the main method. So if I want to access everything from this dog class, I want to access everything from the dog class, right? So when you can create an object here, right? So I'll create an object of dog. Let's say D is equal to new dog. So now I created an object of dog class, so that through this object I can call this, I can use this variable, I can access this variable, and also I can call display method. So what I will do is the value is already assigned to this variable, so I don't need to change this value again. So I just call the display method. So D dot, I will just call the display method. So now what is an output we will get? Very, very important here. So here I created an object of dog class. Okay. So in the dog class object I created, so I'm just calling this display method. So what the display method is doing, it will print the value of the color. Now what is the color it will print? So whatever is the latest color we updated, so that color will print. Because this value, even though this method variable comes into dog, but still it is always considered the latest value. Because we are override this method here, right? Suppose if I don't create this variable, still it will print a white color. So when I run as Java application, it will give you white. Okay, because dog is acquired everything from class animal. So I can access color variable here. When I say color here, it is giving the value from the parent class. Suppose if I override that value in the child class, now the latest value will be printed. So black is printed. So this functionality is perfectly right till here. Now what I want to do is, even though I call my display method, I want to print the value of my parent class variable. So by default, it is printing the value of child class. So child class variable value, it is printing, that is the latest value. But still, I want to access parent class variable value. How we can access, how it is possible. So that means I want to get the value of immediate parent class instance variable. That is the first point that we discussed. Super can be used to refer immediate parent class instance variable. What is immediate parent class instance variable means? This is an immediate parent class instance variable for this particular class. So here we are just printing the color variable. This is the latest variable. But if I want to refer this immediate parent class reference variable, I have to use super keyword. I will create one more statement. Here I'll say super dot color. Super dot color. So what the super keyword is representing? Immediate parent class it is representing. So in immediate parent class, whatever color is there, so that value it will print here. So here it will print white color and here it will print black color. Okay. Now we are calling display method only once here. So now when I run this, it will print. First statement is printed white and first statement is printed as a black because that is the latest value, and second is printed as a white because here we are referring the immediate parent class instance variable. So that is a use of super keyword. So as soon as we override this value, when I call this method, and this method will print only the latest value by default. So the old value is gone because we have override with the new value. But still, if you want to refer the old value, that means immediate parent class instance variable, if you want to refer, we have to use super keyword here. So now the display method will invoke the super class or parent class variable. Okay, so this is a first usage of super keyword. So super keyword used to refer immediate parent class instance variable. This is the first point. Now come to the second point. So guys, are you clear? The first point, everyone, please confirm on the chat window. Everyone is clear? The first point. All right. So now come to the second point. Super keyword can be also used to invoke immediate parent class method. Immediate parent class method. Immediate parent class method. So this time what I will do is I will override eating method. Okay, eating method, I'm recreating here. Again, I'm recreating eating method. And here I will change the body. So that means this is overriding, right? So when I create the same method again here, that means it is representing overriding. Overriding means we should not change the definition, we should change the body. So here I will just say eating bread. So now I have changed the body of the method, right? Now in the parent class eating method, we have just only eating. In the child class eating method, we have eating bread. So now I have two methods. Now what I will do is here, I'll comment this display method for now. And through this object, I will call eating method. Eating method. Now which method will be called? So when I say d.eating, the d is an object of dog class. So from this dog class, eating method will be called. So in eating method will be called, here it will print eating bread method. Right? Eating bread is the output it will give. Because this is the latest method we override. We have recreated this. So parent method is gone. Okay. So now we'll get the output from this child class. When I run this as a Java application, now we will get the eating bread. So this is an output which is giving from the child class method. Suppose if I don't create this method, what happens? Dog class acquired everything from the parent class animal. So it will print the output from the parent class. So when I run as a Java application, it will print that value from the parent class method. But when I override this method in the child class, so the new method is created here. So the latest method will be applied. So whenever I called eating method, it will give the value from the latest method in the child class. But now my requirement is, still I want to invoke the parent class method. So by default, this eating method is invoking child class method. So I'm getting the message from the child class method. But from here, I want to invoke my immediate parent class method. So I want to invoke immediate parent class method. How it is possible? So this is possible here. I will just say super dot eating. So now what happens when I call eating method? First it will print this message eating bread, And then if I want to invoke my parent class method, suppose if you don't want to print this message also, just comment this. Okay. Now when I call this eating method here, first child class eating method will be called. Now internally this eating method again invoke the parent class eating method. So super is representing the parent class. Super dot eating. So in the super class, whichever eating method we created, that method will be invoked. Now when I run this code, it will give you the output from the immediate parent class method. So you still have this method, still have this statement, then it will print two outputs. So the first output is eating bread. This is the message is printed. Then it is invoked parent class method and it is also giving the same message. So this is how we can use super keyword in second one. So the first one we have seen, super keyword can be used to refer immediate parent class instance variable, and super keyword also can be used to invoke immediate parent class method. Immediate parent class method. So these are the two different usages of super keyword. Okay, and this is used only within the inheritance only. So within the only inheritance, we have to use super keyword. Super is representing the class, parent class. Super is representing the parent class. And one more thing is, we can access only immediate parent class. Suppose you have multiple parent classes, from all those classes we cannot access. Only immediate parent class variables and immediate parent class methods we can access using super keyword. So that is all about super keyword. Okay. So now let's move on to the next one called final keyword. So final is one more keyword. So basically final keyword is applied for classes and can also applied for methods and also can be applied for variables. So different levels we can apply final keyword. But the behavior will be different. So when I apply final keyword for the class, the behavior is different. And when I apply final keyword for variables and methods, the behavior is different. So now we'll see how to use this final keyword. So the first final keyword. So I'll start with the variables. I will start with the variables. So let's create another class. Okay, just a moment. So let's start with the variables. Okay, I'll create one new class. I will name it as a final variable demo. This is very simple concept. So please focus. Final variable demo is a simple one class. So here take this main method, then finish it. So this is just a final class, right? So what I can do here is I'll create one variable here. Okay, so integer. I'll just create something called some variable called a speed is equal to some 100. So this is a normal variable. Okay. So if you want to change this value, you can change in the main method. So how we can access this variable in the main method? So this is a non-static variable. So main is a static method, right? So if you want to access this variable, we must create an object. So through object only we can access. So I will create an object for final variable demo class. Let's say fm is equal to new final variable demo. Why we need to create an object here? Because variable is a non-static, main is a static method. So both are different, we cannot access. So if you want to access, then we have to create an object, and through object we can access. So fm dot, I'm accessing this variable speed, and I'll change this value here to 100. Okay, now I can print this value. So I'll just print that value of speed. System dot out dot println. I'll just print the value of this fm dot speed. Fm dot speed. Okay, so now what is the value it will print? It will print the latest value. So 200. So currently default value is 100, but if I don't add any new value, it will print only 100. 100 is printed. But here I have modified this value. I have modified this value so that it's giving the new value. This function is perfectly right. Now what is my requirement here is, once I created this variable with some value, I don't want to change this value anywhere else. I don't want to change this value. I want to make this value is constant. I don't want to change this value anywhere else. Then I have to specify this variable as final. So as soon as I final here, it is giving error here. See, the final field, final variable demo.speed cannot be assigned. Cannot be assigned means this variable is a constant. We cannot modify or change that value. Okay, so this is a kind of restriction level access. So when I say a variable as a final, the value of that variable cannot be changed. The value of that variable cannot be changed. So this is incorrect. Okay, so this is incorrect. So it will give you compile time error. So compile time error means here itself it will give you error. So if I change this, if I remove this final keyword here, then we can able to access here. Okay, so when I run this, it will throw an error. But here itself it is showing an error, right? So we cannot execute this code. So this is incorrect. So it will throw compile time error. So that's the first point. So final keyword, the final keyword. If I apply final keyword for the variables, you cannot change the value of that particular variable. You cannot change the value of that particular variable. That's the first thing. Now, so when I apply the final keyword for the method, then what happens? So when I apply a final keyword for the method, that method we cannot override into child classes. That method we cannot override into child classes. So here we're restricting the method, like we cannot override that method in the child class. We are restricting completely. Okay, we are not allowing others to create, we are not allowing others to recreating the method in the child class. To do this, you have to specify final keyword in front of the method. Now let me show you one more example. So right click, new class, and here I will name it as a final method demo. Final method demo. Okay, so here, so I will create one class here. In the final method demo, I'll create one class called, let us say, class bike. So I create one class called as a bike. So here I will create one method called void run. So in this method, I will write simple message system.out.println. So here I'll just say running. Some message I have printed here. So this is a bike class. Now I'll create immediately one more child class. So child is, I'll say, Honda, and which is extends from bike class. So when I extend bike class, this method is again belongs to Honda class. This method is again belongs to Honda class, right? I will override this method in the Honda class. Instead of running, here I'll just say started. Okay, some message I have changed. So I'm able to override this method in the child class without any issue. Now what I want to do is, I don't want to allow this method to override in the child class. Then I can make that method as a final method. So as soon as I final here, in the child class, it will not allow you to override that method. So it is giving an error. So when you put the cursor here, it will clearly say, cannot override final method from bike class. So what does it mean is, we have just restricted this method without overriding. So I don't want to allow this method to override in the child classes. In that case, we can specify that method as a final. So what we understood here is, if I apply a final keyword for the method, that method cannot be override in the child classes. A method cannot be override in the child classes. So in this context, here it is incorrect. This is incorrect. It will throw compile time error. Okay. So this is the usage of final keyword when you apply it for the methods. So when I apply final keyword for the variable, the value we cannot change. If I apply final keyword for the method, we cannot override that method in the child class. And now we can also apply final keyword for the class. Then what happens? So when I apply a final keyword for the class, we cannot extend that class into another class. So when I create a final class, that class cannot be extended into another class. We have completely restricted extending the class. Okay. So here what I say here in the same method variable. So here what we have done is, by class is extended here. Okay, by class is extended here. But when I say final here, then here it will start showing an error. So what is saying here, the type Honda cannot subclass the final class bike. So what does that mean? Bike is a parent class, Honda is a child class, but because of final keyword here, we are not able to extend. We are not able to extend this class into child class. We have restricted access level. We have restricted completely. I make this class without using any subclass. So we cannot create any subclass for this particular class. So that is the use of final keyword. If I create a final class, that class cannot be extended into child class. We have restricted that one. Okay, that is the use of that is the use of final keyword. So final keyword can be used variables, methods, classes. When I create a final variable, those variables are constant, so those values we cannot change. And when I create a final method, the methods cannot be override in the child classes. And when I create a class as a final, the class we cannot extend into the child class. The class cannot be extended into the child class. So these are the final keyword is basically restricting the access levels, nothing else. Okay, so this is all about final keyword. So we have seen super keyword and final keyword. All right. So today we have discussed about 3 types of inheritances, and rest of the 3 we will discuss tomorrow along with the interface concept. And we have discussed about method overriding and differences between method overloading and overriding. Then we have discussed about super keyword and final keyword. So these are all important topics from inheritance concept. And tomorrow we'll see one more concept called interface concept. All right, so I'll stop here in today's session. If you have any queries now, you can ask me. All right. So today we are going to discuss about 3 different topics from Java. So one is Java interfaces. Next one we discuss about packages, and then access modifiers. So yesterday we have talked about inheritance concept. So there are 5 different type of inheritance concept we have. One is single inheritance, multi-level inheritance, hierarchy inheritance, multiple inheritance, and then hybrid inheritance. So as I told you, first 3 types of inheritances are possible using class concept, but multiple and hybrid. So these 2 types of inheritances are not possible using class. So we need to go for interface concept. So interface supports will that. Interface supports multiple inheritance and also hybrid inheritance. So let us see what is interface. First we need to understand what is an interface, how it will be, how to create an interface, how to work with an interface, and what is the use of interface. And then we'll discuss about how to use this interface to achieve multiple and hybrid inheritances. So first let us see a few important points about interface. How the interface is different than class. So here there are a few points I have noted down. So what is an interface? An interface in Java is a blueprint of class. An interface in Java is a blueprint of class. So what is blueprint of class means? It's the syntax of the interface almost similar to class. So just instead of using class keyword, we use interface keyword. That's the only change, but rest of the things are same. So that's the reason we say interface is a blueprint of class. And the second point is interface contains final and static variables. So these point is very important. Interface contains final and static variables. So what is final and static variables? When I say a variable as a final, that value of that variable is constant. So we already discussed about these 2 keywords earlier sessions, right? Final variable means that variable value we cannot change. So once we have applied that value to the variable, that is fixed. So that value we cannot change. That is the final. And static means without creating any object, we can directly access those variables using class name. So that is about static. So when I create a variable within the interface, those variables are by default final and static. So we don't need to explicitly say final and static. By default, interface contains final and static variables. We cannot create normal variables in interface. Okay, so in interface contains only final and static variables by default. But in the class, it is not like that. In the class, the variables are normal. If you want to make them as a final, we have to add a final keyword, or if you want to make them as a static, we have to add a static keyword. But in the interface, whenever you create a variable, by default it is a final and static, even though if you don't specify those keywords. Okay, that's a one behavior. That's a behavior of interface. Next one is interface contains the abstract methods. Interface contains the abstract method. So here we need to understand what is an abstract method, what is a normal method. So normal method means we will have some return type, or if the method is not returning anything, so we say void and name of the method and number of parameters. And within the method, we can write some logics. So that's a normal method. What is an abstract method? Abstract method means a method which contains only the definition but not the body. That means it contains only definition but not implementation. So a method without having any logic. Simply say a method without having any logic. We simply specify the definition. So that's called as an abstract method. But I'll tell you what is the use of method if I don't implement anything, right? So we'll discuss that. So abstract method is a method which contains the only definition but not the body. There's another point. Next one, interface supports functionality of multiple inheritance. If it is able to support multiple inheritance, it can also support hybrid inheritance, because hybrid inheritance is a combination of hierarchy and multiple. Hierarchy will automatically supported by the class, but multiple is not supported by class, so that we come to the interface concept. So it supports multiple inheritance, so that it will also support hybrid inheritance. Then we can define an interface with interface keyword. So how we created classes, same way we can also create interfaces, but only the keyword will be changed. Instead of class keyword, we use interface keyword. And the next point is the methods in interface are public. So public is basically an access modifier. There are 4 types of access modifiers we have: private, protected, default, and public. So public is nothing but it's a completely open. So those methods can be accessed within the method, within the class, outside of the class, outside of the package, everywhere. So interface contains the methods. Those methods are by default public. Even we don't need to specify any access modifier for those methods. By default, it is a public. But in the class, methods are default. In the class, if I create any method, we have to make intentionally either private or public or default, whatever. We have to specify the access modifier. If I don't specify any access modifier, then it will be considered as a default in class. But in the interface, by default, the methods are public. Okay, so these are the important bullet points which we need to remember before creating interface and before working with the interface. Now I'll show you a few examples how to create an interface and everything. But what is the use of interface? As I said, interface contains abstract method. So only we have some variables. Other than this, we don't have any methods. But if I don't create any implementation for those methods, what is the user of interface? Why we need to create this interface? Because there are some scenarios we have. So for example, sometimes what happens is in the real-time environment, or developers or tester, whatever, they need some, they should know 2 things importantly. So if you start writing your code, you should know 2 important things. What are those 2 important things are? The first one is you need to know about the requirement. So for what purpose you are going to start writing your code. So requirement you should know. That's the first thing. And once you know the requirement, you should know how to implement this requirement. You should know how to implement this requirement. So these are the 2 important things you need to know before starting your coding, either developer or tester. Requirement means it is a what we are going to develop or implement, and how we are going to develop or implement. So how is nothing but basically this is design. Okay, so design is nothing but how part. So requirement we should know, design we should know. So requirement says what to implement, design says how to implement. Okay, this is the basic things we need to know before starting your coding. Either it can be automation code or development code, whatever. So requirement we should know, and how to design that requirement we should know. So requirement contains what to implement, and design says how to implement. But some situations, what happens is we know the requirement at the initial stages, but we don't know the design part. We know what to do and what to implement, but how to implement we don't know. And because some documents are not yet ready, or still there is a time to get the design documents and everything. But as of now, I know only the requirement, what to do and what to implement, but I don't know exactly how to implement them. So in those situations, what the developers will do is they will create an interfaces. So initial level, at the first level, beginner level, they will create interfaces. And within the interface, whatever the requirement they know, for each requirement, they will create multiple methods. So these methods are abstract methods. Why we call them as abstract methods? Because these are the just method definitions. These method doesn't have any implementation, because we don't know how to implement this as of now. So we just create methods abstract, and then later we will implement these methods by using class. But if you want to implement these methods within an interface, we cannot implement. So interface allows only abstract methods. The implementation part, it will not allow. But what is the use of interface in that case is, at the initial level, if you know only the requirement, then we have to create an interface with some kinds of abstract methods. And later point of time, once we know the design part, like once we know how to implement these methods, then immediately we don't touch this interface still there. We will create one class, okay? And this interface is implemented by this class. This interface is implemented by this class. Means what? These all the methods we have to implement using a class. So without a class, there is no use of interface. Remember this. So interface alone cannot achieve anything. So interface alone, we cannot do anything. So interface along with the class will be useful. But when we need to prefer to create an interface, if you know the requirement, but you don't know if you don't know the design part, then you initial stages you will create a interfaces, and which contains some abstract method, because you don't know the implementation part. But once you know the implementation, you don't delete this interface. Okay, don't remove this, because already this interface contains n number of methods you already created. Only thing is the implementation is not there. So immediately you will create a new class, and these methods, abstract methods, will be implemented in this class. Okay, now this is a parent interface of this child class. Okay, so this is how we need to approach. So interface alone, no useful. So interface, if you want to implement this interface, we must create a class, and using class we have to implement all these methods. So this is a situation where we need to prefer to use interface. Even Selenium WebDriver is also started like this. Selenium WebDriver is an interface. So whenever you get this kind of questions, what is a WebDriver? What is Selenium WebDriver? The first and most important answer will be Selenium WebDriver is a Java interface. Because at the beginning days, they don't know exactly how to implement this automation frameworks and everything using Selenium. So they know some requirement, that's it. So they have created some WebDriver interface initial level. They created a lot of abstract methods inside this. And then they have implemented multiple classes for those same WebDriver interface. For each browser, for Chrome browser, they created Chrome driver class. For Internet Explorer, they've created Internet Explorer class. So they have created multiple classes, and those classes have implemented WebDriver interface. Okay. So again, I'll talk about this topic in the coming sessions in detail. For now, just remember, interface is a blueprint of class which contains only final static variables and abstract methods. And if you want to implement those interface methods, we must create a class. Without a class, there is no use of interface. Okay. So this is the basic understanding of interface. Now we'll see an example how we can define interface, how we can use this interface. Next one. So let's go to Eclipse. Now here, this is our current project we are working on. So I'm just creating a new package for today, day 9. So under day 9, I'm creating. So by default, I'll start with that class itself. Okay, so class is mandatory required. Interface alone, no useful. So I'll just take a class, and here I will just give some name for some test and take this main method, then finish it. So this is a class basically, right? Test is a class. So we'll use this class later. So keep this class one side. Now I'm going to create an interface. So let us say interface A. So even interface names also start with the uppercase letters. The naming conventions are same for class as well as interface. Okay, so interface A is an interface, and inside the interface, as I said before, it contains only static and final variables and abstract method. But how we can define them? So when I create a variable here, observe this, integer A is equal to 10. So as soon as I define a variable, see now that variable is changed as a italic format. So it is a static and a final variable. So the value of this variable cannot be changed in future. So this is fixed value. So in interface by default variables are static. So by default variables are interface or static and final. Static and final. So by default variables in interface are static and final. And similarly, I will also create one abstract method. So how to create an abstract method? So abstract method means we have only definition part, but we don't have any implementation. So how to create return type, name of the method, and close and semicolon. So normally methods, we don't specify the semicolon, but this is an abstract method. We don't have any implementation, so that we have to end with the semicolon. Okay, so this method is not implemented, just we have defined this method. And if sometimes method is required certain number of parameters, so we need to also specify the parameters here. So parameters also part of your method definition. So we must create a method like this. This is a abstract method. This is your abstract method. So in interface, all methods are abstract. Okay, so in interface, methods are abstract method. By default, it is a public. So we don't require to specify any access modifier here, public or private or whatever. But by default, it is a public. By default, it is a public. But if it is a class, by default, the method is default access modifier by default. So this is a interface definition. So this is how we need to create an interface. Now, if we want to use this interface, we must have a class. So without class, there is no use of interface. So now I'm going to use this particular class. So we already have the main class, right? Test. So now what I will do is I want to use this interface, means I want to implement this method using a class. So here we have to use a keyword called implements. Okay, so in previously we have seen extends. So in inheritance concepts, we have seen extends keyword, right? Class to class, we do extends. But here, interface to class, we do implementation. So class test implements interface name. Implements interface name. So this is how we need to do. So here we need to remember a few important things. Okay, so they are, for example, I have a class and there is another class. So if you want to use inheritance concept, class to class, we use extends keyword. Class to class, we have to use extends keyword. And interface is there and a class is there. So interface contains only abstract methods. So if you want to implement those abstract methods in the class, we have to use implements keyword. Implements keyword. Interface to class implements keyword. Now, interface to interface. Interface to interface. One is parent interface and child interface. So the parent interface contains abstract methods and final static variables. Even child interface contains its own static and final variables and abstract methods. So here we use extends keywords. Here we are not going to implement anything. So here suppose there is a variable or called m1 is method, there is a variable called x. And interface I, this is I1 and this is I2. So this interface contains y is a variable, m2 is a method. And everything is an abstract, even in the parent interface and child interface. So the parent interface we are extending to child interface. Okay, but if you want to implement these m1 method, m2 method, then we need a class. So we must create one more class here. Here we have to do implementation. So in this particular class, we have to implement all the methods from interface 1 and interface 2. Okay, so interface to interface, we use extends keyword. These are the three important scenarios you need to remember. Class to class, we use extends keyword. And interface to class, we have to use implements keyword. Interface to interface, we use extends keyword. Okay, but class to interface is not possible. Class to interface is not possible. Okay, because class is having a implementations, but how we can acquire everything into interface? Interface contains only abstract method, right? There will be some conflict, so we cannot do that. So class to class, we use extends keyword. Interface to class, we use implements keyword, because we have to implement these interface methods in the class itself. And interface to interface means both interfaces are having only abstract methods, so we can do extends. Now for I to interface, we have to create one more class, and using that class, we have to implement those methods. Okay. So class to interface is not possible. So these are the three scenarios you have to remember, and very important. Now here I have used implements keyword because test is a class, A is an interface. So when I say implements A, we must implement these methods inside this class. So main method is method which keep this main method one side. Now along with this main method, right, I must implement this method inside this class. So I must implement this abstract method inside the class. But how to implement? Now we'll write this. I'll say void m1. So we should not change any definitions. So void m1, and here I will write the definition. So here I'll just simply say system.out.println. I'll print the value of A, because A value already there. So A value already belongs to test class. So because we say implements A, right? So whatever is belongs to interface A, which is also belongs to class. And this is again simply inheritance concept. But only thing is, because this is an interface, we must use implements keyword. If it is a class, we have to use extends keyword, and rest of the things are same. Now this abstract method we must implement in the child class. Okay, so now I have implemented this class, I have implemented this method, but still it is giving some error. So why it is giving an error? If I put this cursor here, it's clearly saying cannot reduce the visibility of the inherited method from A. This is very, very important one. And what we have to do, why it is giving is, the fix is also it is giving. So the what is the fix it is giving is change method visibility to public. Change method visibility to public. So as I said one point before, in interface, methods are by default public. In interface, methods are by default public. So here interface, when I create this method is a public. But when you create a method within the class, if I don't specify any access modifier, that will be treated as a default access modifier. So default. So there are 4 access modifiers we have. Let me show you. One is a public, and then we have a protected, or then we have a default, and then we have a protected, then we have a private. So these are 4 access modifiers. And access modifier means it will restrict the access levels of your methods and variables. So for example, if I say public, so those variables and methods can be accessed anywhere in the project, within the method, within the class, outside of the class, outside of the package, everywhere. And when I say default is, the default access modifier, those methods and variables can be accessed within the package. And protector is also similar kind of access modifier. So when I say private, those variables and methods can be accessed only within the class. Outside of the class, we cannot access. So basically, these are the access modifiers we have to use to restrict the access levels of variables and methods. Okay. So here, public is a very high level. So public is completely open. So we can access everywhere. And default is little lesser than public. And protected is more lesser than default. And private is completely restricted. Okay, we cannot access anywhere else other than the class. So when you compare with the public, default is lower one. And when you compare with the default, protected is still lower one. And private is completely lower than other access modifier. Now, what we are doing here is, in the interface, the method is a public. And when I'm trying to implement this method in the class, I don't specify anything here. So if I don't specify anything, that will be treated as a default. Okay, in the class, if I don't specify anything, like in the class, the methods are default. So what we are trying to do here is, in the interface, the methods are public, but in the class, it is treating as a default. So default is lesser than public. So here the rule is, in the interface, the methods are public, so that here we must use the same kind of access modifier. That means it should be public, or at least it should be higher than the existing modifier, but it should not be lower than existing access modifier. So here it is a public, here it is a considering as a default. So default is a lower than public. So what we are doing, we are reducing the visibility. We are reducing the visibility. So that's the reason it is giving an error. So there are two solutions we have. So one solution, either we have to specify this method as a public here, or we should specify the little higher modifier here, higher than public. But public itself is a higher modifier. We don't have any other modifiers which are higher than public. So there is only one way to solve this problem, is you have to specify the public access modifier. Okay, that's the solution for this. So whenever you are trying to implement this interface methods within the class, we must specify the public access modifier. We should not forget this. Okay, so in interface, by default methods are public. So in the class, by default methods are default. So there is a conflict. So that's the reason we should not reduce the visibility. We can increase the visibility, but we should not reduce it. So we have to specify this is a public. So that issue is being solved. All right, so now we created an interface and we have implemented this abstract method within the class. Now how we can call this method? So come to the main method. Let's create an object for the class. Now one more important thing. So we have a class and we have an interface, right? So for the class, we can create any number of objects, but can we create an object for interface? So we cannot create an object for interface. We cannot instantiate an interface. We can create an object reference variable just like a class, but we cannot instantiate interface. So what does that mean is, here there is an interface called A, right? So if I say A, some object is equal to new A. So this is not possible. Okay, so here this portion is called instantiation. This is just object reference variable. Okay, this is an instantiation and this is object reference variable. So object reference variable we can create, but we cannot do instantiation. So when I do instantiation, we must use a class name which is implemented by this interface. So here, what is the class name? Test. So we can use a test here. This is the right notation. So instance is test, but the variable is referring with the interface. So this is the right one. So we can create object reference variable for the interface, but the instantiation will be done using a class only. We cannot instantiate interface. That's important point. And this is exactly equal to this one. So you can also create the test class object, right? When I create the test class object is equal to new test, you will do that. So this is also exactly the same as the above one. So either you can go for this approach or you can directly go for this approach. Both are same. Only thing is we are just changing the reference variable, but the object is same. Here it is a new test and here it is a new test. So this is a code which will create the memory location for the object. So as soon as I say new, this one will create the memory location for the object. So once it is created the memory location, we can refer that location by using any of these variables. Either that variable can be class variable or it can be interface variable. Okay, so we cannot create an object, we cannot instantiate this interface, but we can create an object reference variable for the interface. So this is another important point which we need to remember. So now I created an object. So through this object, I can access method M1. Okay, that's it. Now let us run this code as Java application. Now we can say the value is printed as a 10. So this is how just we need to implement. We have to define this interface, create an interface, and then implement this interface using a class. So whenever you are implementing this interface, we must use implements keyword. That's one point we have to remember. The next point is whenever you are implementing this method, we must specify the public access modifier to that particular method. Okay, so this is an example of how we have to define the interface, how to use this interface. In the next example, I'll show you how to implement multiple inheritance concept using interface. Now we will see. So access modifier I'll discuss in detail in next few minutes. Just keep this one side. So now I'm going to implement multiple inheritance using interface concept. So multiple inheritance using interface concept. So how we can achieve this? So what is multiple inheritance? So multiple inheritance means we have a multiple parent classes for one child. Don't say classes or interfaces here. Just say generically there are multiple parents for one child. Okay, that's the main concept of multiple inheritance. That means A is a parent, B is also a parent, C is a child of A and B. So this is called as a multiple inheritance. So one child can have multiple parents. So in this particular context, if I create A is a class and B is also a class, so I cannot extend two classes into one class. Like I cannot write C extends C extends A comma extends B. I cannot write like this. That's the reason class is not supported multiple inheritance. So instead of class, I will create A and B or interfaces. So I'll make I is interface, B is also another interface. Okay. Now these two interfaces contains only abstract methods. So these two interfaces I will implement using this particular class. But I cannot extend multiple classes, but I can implement multiple interfaces. So that's the concept is here. If both are classes, I cannot write a C extends A comma P. I cannot write like this. This is incorrect. But if they are interfaces, then I can write like this. C implements A comma B. So here A and B are interfaces. So I can implement method from these interfaces in the C class. But if they are classes, I cannot do extends. So that's the problem with the class. So now let us implement this inheritance concept, multiple inheritance using interface concept. So we have to define these two parents as a interfaces and one child as a class. This is a class. Okay. Now let's go to Eclipse. So I'll create another example. Right click, new class. I will name it as multiple inheritance demo and take this main method and then finish it. Okay, so now just keep this class one side. I'm just using this class as a child class later. Okay, so for now, I'm just going to create two parents. So those two parents are interfaces. Okay, so I'll just create one interface, let's say ABC. So this is my interface. ABC is my interface and which contains a variable called integer x is equal to, let's say, 100. And we must specify some value here, okay, because final variable, by default, we need to add some value if it is a final variable. So in interface, the variables are final by default, so that we must assign some value to them. Okay. So remember, so this is a variable I created, and I will also create one abstract method called void m1. So this is an abstract method. So this is one parent. Now I'll create another parent, interface xyz. This is also another parent, interface xyz. Here I'll say integer y is equal to 200. So integer y is equal to 200. So this is another interface which contains a variable called y, and one more abstract method I'll say m2, void m2. So these two are two interfaces. These two are two interfaces. So let me just write it over here. I created ABC. This is an interface, and xyz. So this is also interface. So this contains m1 method, this contains m2 method. Now, if you want to implement these two methods, we must have one child class. I will create one child class here. So I'm using this multiple inheritance demo is a child class. Multiple inheritance demo is a child class. So here I will implement m2 method and m1 method and m2 method. And then ABC and xyz are the parents, and this one is a child. So this way we can achieve the multiple inheritance. So now let us implement and try this. So these are ABC and xyz is created. Now I will implement these two methods using a class. So this is a class I'm going to use it here. So how we can write the statement now? So here I'll just say implements ABC, comma XYZ. So like this, we can add any number of interfaces. If you have 10 interfaces as a parent, you can keep on adding 10 interfaces by separating comma. Okay. So implements ABC and XYZ. So when I say implements ABC and XYZ, in this particular class, we must implement M1 and M2 method. Otherwise, it will not allow you. It will throw an error. So the type multiple inheritance demo must implement the inherited abstract method ABC M1. So first it will show only M1. Once it is implemented, then it will show you M2. Okay. So M1 and M2 we must implement using this class. So let us implement those two methods here. So M1 is a method, right? So when I say void M1, let's say void M1, and whenever you're trying to implement a method, don't forget we must specify the public access modifier. Okay, because interface contains only public methods. So when you're implementing those methods, we must specify the public. So here I will create a message called system.out.println. I'll just print the value of X here. Okay, done. So now I have implemented first method. So now if you go and see here, it will show you another error. To type multiple inheritance demo must implement the inherited abstract method xyz.m2. So now we need to implement xyz.m2 method. So let's implement that also. So public void m2, and inside this I need to specify the y. So this I just print the value of y in m2 method. Okay, so now I have implemented both the methods which are coming from ABC and XYZ. Now, if you want to call these methods, we have to create an object. So where we have to create in the main method. So we have to create an object for this particular class. And multiple inheritance demo, I'll say mi is equal to new multiple inheritance demo. And using this particular object mi, I can access m1 and then mi.m2. So this is how we need to implement multiple inheritance. So one child can have two parents. Okay, let's run this code. So it will print 100 and 200. So this is how we need to implement multiple inheritance using interface concept. So here we make both the parents or interfaces, and then it is possible. Okay, if both parents or classes, it is not possible. So we cannot extend two parents into one child class, but we cannot implement two interfaces in one child class. Okay, that's the same thing I have done here. All right, so this is how we need to implement multiple inheritance using interface concept. Now we can also implement hybrid inheritance. So let us see how we can implement hybrid inheritance using interface concept. So what is hybrid inheritance? That we need to understand first. So guys, are you clear so far? So two examples I have told you. Everyone is clear? So you can just write some logic in the M1 method and M2 method. So for example, what I will do is I'm printing X value, right? So instead of printing X value, I can just add something else. Let's say X plus 100 I will add. And here Y plus 100 I will add. Okay, this is also simple logic. So you can write some logics also here. So for example, let me run this code, Java application. So now it will give you 200 and 300. 200 and 200. So because X value is 100 default, we have added additionally 100, so it becomes a 200. And M2 method, Y is there, so we have added 100, so it will become 300. So now here we are not changing the values of X and Y. Remember this, we are not changing the values of X and Y. X value is still 100, but we are additionally adding 100. So total value is 200 is printing here. This is output, but this is not the value of X. So still X value is 100 here, Y value is 200 here. It will not, we are not changing here, remember. Okay, we are not changing the values of X and Y. We are adding some additional number with the existing value. But this is not X plus 100 means X is 100, additionally added 100, 200 is a not X value. 200 is a not X value, that is a output or result. Okay, so X value is still 100 only. X value is still 100. Okay, don't think like this. So X value is still 100, Y value is still same 200. So we cannot change this value. But we are additionally adding something else. Okay, so we can also write different logics and we can also pass parameters to these methods, but everything should be part of definition. If suppose these methods are taking some parameters, those parameters we must specify in these methods. Okay, parameters we must specify, but implementation, this is up to you. Whatever you can implement, logics you can still write it. Okay, so there is no restriction there. All right. So now let us see how we can implement hybrid inheritance using interface concept. Now, what is hybrid inheritance? So what is hybrid inheritance? Let me just write it over here. So in hybrid inheritance is a combination of hierarchy plus multiple. So for example, let us say, one second. Okay, so what I can do here is I'll just draw some small picture here. Let us say I have, let's say A1 and B1. Okay, A1 and B1. And I'll create one child for these A1 and B1. Okay, so A1 not B1. So let's say, okay, I'll take another variables. You can simply understand. Let's say A, B. Okay, so this is a C. Okay, this is a 1. Okay, and here I will say something else. Let me draw correctly. So for example, A is there. Okay, so here is a B and here it is C. This is what kind of inheritance? This is hierarchy inheritance. So this is possible using class. So two child classes. So B is extended from A, C is also extended from A. So here in hierarchical inheritance, classes can be used. So here there is a problem. So when I say D here, so this is a multiple inheritance again. So this is a hierarchy. This is a multiple. So combination we can call it as a hybrid inheritance. So this is a structure. So this is a hybrid inheritance structure, right? But where we have to use class, where we have to use interface, that's the main challenging here. Okay, which one we have to define as a class, which one we have to define as a interface. Now observe this carefully. So here ultimate goal is in the D must be a class anyway, because here this is ultimate one. So here we need to implement everything, right? So we have to create object for D itself. So D is a grandchild of B, C, and A. These are all parents, and D is a grandchild. So D should contain everything from B, C, as well as A, everything. So now if you think about here, B and C are the parents of one class, one child. So if you have two parents for one child, normally we'll make them as an interfaces, right? So let us make this B as an interface and C is also an interface. If B and C are the interfaces, then we can implement these two interfaces using D class. Okay, fine. But what about this A? So A I will define as a class. I will define A is a class. Okay, and then if it is a class, D is also class. I can directly extend this class D, right? So ultimate goal is D should contain everything. Okay, so now B, C are anyway we will implement using D class, but I will also extend all the stuff from A to D. But A to B, A to C is not possible because A is a class, B is an interface. Class to interface is not possible because class means it contains all implementations and C contains all the implementations. But if I create A interface, that is also fine. If A is an interface, I can make A to B, A to C. But again, we have a duplication. Because when I say A is an interface, so here I can use extends keyword, here you can use extends keyword. But B contains A, C is also contains A. And ultimately, D will get the duplicates. Oh, so that's the reason I make it A is a class here. When I make A is a class, then what happens? D is also a class. So B and C will be implemented by using D. And A will extend by using D. So A is a class itself, right? So A will extend into D. So ultimately we will get everything from B, C as well as A. So this is how we need to achieve hybrid inheritance. Okay, so let us see how we can do this, how we can implement this. So let us start creating a hybrid inheritance. So here I'll just say new class hybrid inheritance demo, take this main method and finish it. Okay, so here this is a class, so this is a grandchild. Okay, create this, make it as a grandchild. So now what I said here is, so two interfaces we need. So let us say this is a class, and this is an interface, this is an interface, and these two interfaces we have to implement using class, and this class also directly we have to extend using this class. Okay, now this class contains everything from all the parents. So this is the context. So let us try to implement the same thing. So first I will create this class, so the parent one. Okay, so here I will name it as a class A1. So I will also give some names to them. So let us say this is your A1, and here interface, this is I'll say B1, this is I'll say B2, and this is a normal class. Okay, so now here I'll create A1 class, the first one. So class A1, and the same class name we should not use, like, because the same A, B, C we already used in the previous examples, right? So we cannot reuse again same thing, because everything is under the same package. So class A1 I will implement here, because this is a class, so we can implement the method directly. So let's say void m1, and inside this I will write system.out.println. Okay, I say this is m1 from A1. Okay, this is the message I'm just printed. Okay, so now this is a parent, grandparent. So A1 class, I have implemented this method directly. Now I will create B1 and B2. Okay, but A1 and B1, A1 and B2, there is no way related. Okay, because class to interfaces is not possible. So here I will create B1 and B2 as an interfaces. So I'll say interface B1. So here I will create an abstract method called, let's say, M2. So this is an abstract method, because interface contains only abstract methods. Now I will create another interface called B2. This is also another, this also contains another abstract method called M3. Okay, so B1, sorry, we don't record brackets here. So interface B2, and this also contains one more abstract method called as a M3. So now come to the main class. So now we have defined A1, B1 and B2. Now we are implementing actual class, hybrid inheritance demo. But how we can extend everything, how we will get all the parent classes here. So the first thing is, we have to extend the class. Which class? A1 class. So here first I will use extends A1. Now what happens? Whatever is belongs to A1, that is also belongs to this particular class, hybrid inheritance demo class. So now we get everything from A1, followed by implements B1 comma B2. So this is how we need to write the syntax. So first we need to start extends keyword and specify what is the class we have to extend, specify the class name, followed by implements and specify all the interfaces separated by comma here. Okay, so one keyword we have to use, we can write any number of interfaces here. So now what happens? This particular class get everything from A1 and also get everything from B1 and B2. But only the change is A1, the method is already implemented, so we no need to implement again here. But from B1, B2, whatever all methods we created as abstract methods, we have to implement those two abstract methods within the class. So that's the only thing we have to enhance. But A1, we already implemented this method because this is a class, so we don't require to implement this method again. Only thing is we have to implement B1 method and B2 methods. Okay, so let us try to implement here. So void m2. So here I'll create a message. I'll say system.out.println ln, and here I will write a message called this is M2 from B1 interface. Okay, now here we have implemented, but when you are trying to implement this method, don't forget we must specify the public access modifier. Specify the public access modifier. Okay, now we have M2 is implemented. Now we need to implement method which is coming from B2 interface, that is M3. So let us implement M3. So public void M3, and here specify the message. So here I'll write the message. So system.out.println, and this is M3 from B2 interface, B2. Okay. Now if you see, hybrid inheritance demo is a class which is extended everything from A1 and B1 and B2. Okay. So now everything we have. So now if we want to access all these methods, we have to create an object for this class. So hybrid inheritance demo. Okay, so hi is equal to new hybrid inheritance demo. Now hi dot the first method M1 and hi dot next method M2 and then hi dot M3. Okay, so this is how we need to call. So M3. All right, so now we have called all the method from all the parents. So from B1, B2, A1, everything. So now it is achieved hybrid inheritance. Now we got output from everything. Okay, so here also we can pass parameters, we can write logics inside the method, everything we can do as usual. Okay, so this is how we can achieve hybrid inheritance using interface and class combination. So class must be there. Only with inheritance we cannot do anything. Okay, so class must be there to implement the interfaces. So this is a concept of inheritance, and we have seen so far all 5 kinds of inheritance types using classes and interfaces, and this is all about interface concepts. Okay, so this is enough for interface. So we know about interface now. So how to declare an interface, what is an abstract method, what interface contains. Okay, so how to implement that interface by using a class. So all these things are we have seen so far. Okay, so any queries on this guys so far on interface concept? Are you guys clear? Now I'll move on to the next topic. So this is all about interface concept. Okay, inheritance we have done, interfaces we have done. Now, so the next concept is very simple concept is packages, and then we'll discuss access modifier. So first let's see Java packages. It is very small and simple concept. We don't need to do anything with the code. So we need to understand Java packages. What is a Java package? So Java packages are, we can simply say, folders which can have multiple files. Those files can be classes, or it can be interfaces, or anything else. So it is just like a folder. A package in Java is just like a folder which contains any kind of file. So it can have multiple classes, it can have interfaces, or it can have anything, or text files, Excel files, whatever you want to keep. You can create simple a package and you can put everything inside the package. So far we are creating the packages. If you see here, every day I'm creating the new package, but how internally it will store. So as I said, the package is simply kind of a folder. So why we need to create the packages? Because to organize your files properly. So for example, in your system, you will have multiple type of files. You will have a video files, audio files, personal documents, movies. There are different type of files will be there. You don't keep everything in one folder itself, right? So you will have multiple folders, and one folder you will keep some personal documents. In another folder you will keep all the movies and audios and other things. So based upon the type of files, you will separate them in multiple folders. Why we are doing this? Because for maintenance. And tomorrow if you want to search for specific file, you can directly go to that particular folder and you can search for that. The same concept is here also. If you have n number of classes, different type of interfaces, different type of files, so we need to keep them in proper way, in proper folders. So in that case, we need to use packages concept. So these are all different packages I created. So I can create multiple files inside the package. But how these packages will be stored inside the workspace? So inside the workspace, these packages will be stored in the form of folders. Now I'll show you how this will be stored. So first of all, let us see the location of your project. Right click on your project, go to properties. Now here, if you go to the resource, you will see the workspace location. This is your current project location. So all the packages, classes, everything, whatever you do here will be stored in this particular location. So I'm just copying this location and go to your folder, Explorer. So here I'll put this location. So now you can see this is the location of your project. But where we can see all these packages as a folders, just go to SRC because SRC contains these packages, right? Now go to SRC. Now you can see all the stuff here. So day 3, 4, 5, 6, 7. So you can just compare these two. So whatever packages are created here, it is created in new packages. But what about these files? These files are coming from the default package. Default means we don't given any pack. We haven't given any package name here. So in those cases, it will be created default package. Inside this, these files will be available. But for the default package, it will not create any folder. For the default package, it will not create any folder. So it will just create the files. Okay, so it is. So if you do something here in the tree, it will affect it here. Okay, so if you remove from here in the folder, it will automatically reflected in the Eclipse workspace, Eclipse tree structure. So this is vice versa. Okay, so package is simply a kind of a folder where we can keep all similar type of files. That is the definition of package. Now we can also create some sub packages. A package can have multiple packages. A package can have multiple packages. So how we can create the sub packages? So if you want to create a sub package, I'll just minimizing here. Suppose I want to create one new package here. Let's create a new package. Let's say pack1. Finish. So as soon as I created the new pack1, if you go and see the folder structure, pack1 is created here. So currently pack1 doesn't have anything. Okay. So when I create some file here, let's create one file. Let me just say the test. Let's finish it. So I just created one plain test file. So under pack1, it is created a new file. So now what I want to do is I want to create a sub package. So normally what people will do is it will right click on this package. Again, it will create a new package. People will do like this. If they ask to create a sub package, they will do like this. Right click on this package, go to the new package, and here they will give some name here. Okay, so suppose they will give some name called pack2. Click on the finish. Now what happens? It is created a new package, but it is not part of your pack1. It's not a sub package. If you go and see, you can see two different folders here. Pack1 is different, pack2 is different. But what I want to do is, I want to make pack2 is a sub package of pack1. Okay, sub package of pack1. So I'll remove from here and refresh your tree here, and it will also gone. So now what I want to do is I want to create a sub package inside this pack1, another package. So how we can do this? So to create a sub package, you have to do like this. Right click on here, go to the new package. So currently where are we? We are in the pack1. Okay. Under pack1, we have to create one more sub package. So we say just say dot pack1 dot as a pack2. So now what happens inside the pack1, it will create another pack2. So click on the finish. Now you can see it is created the new package. But pack2 is a part of pack1 itself. In the tree, it will show you like this. But if you go to the folder, you can see only pack1. So pack1 dot pack2 you cannot see here because pack2 is a sub packages of pack1. So we need to go inside this folder. So go inside this pack1. Now you can see pack2 here. Okay. Now, if I want to create a file inside the pack1, just go to this particular package and create. If I want to create a file inside the pack2, then go and create the file here. So here I'll create another class called test2. So now this test2 will be part of under pack2, not the pack1. Okay. Now if you go and see inside the pack1, so pack1 contains, there is one file, right? So test file is there. Along with there is a some sub package is there. So pack2 is there. So inside the sub package pack2, we have a test2. Now if you open this pack2, we can see test2. So this is how we need to organize packages and sub packages. Packages and sub packages. Okay. So you can create any number of sub packages like this by adding dot symbol. So pack1 dot, pack2 dot, pack3 dot, something like this. Okay, so now one more important thing is, so what is package contains? Package contains multiple classes. Suppose if you want to use any class in some other class, we must specify the package name, in which package the class is coming from. And to do this, we have to use a command called import. Import package name dot class name. We have to specify at the beginning of the code. So whenever you start writing your code, we must specify the import keyword. So if you are going to use this class in some other class, right? So I should import this one. So for example, I'll show you here. I have one pack1, right? So in the package 1, I have a class called 1. C1 class is there. So I am currently in the package 2, and I am implementing C2 class. C2 class I'm implementing. Now here I want to use C1 class. Here I want to use C1 class. I want to create an object for C1 class. Then the C1 is present in different package, right? So what we have to do here, before writing this class to itself, we have to write an import statement. Import from pack1 dot import from pack1 C1 class. Okay, so import C1 from pack1 class, pack1 package. And then I can refer this C1 class inside the C2. Okay, this is how we need to refer if you want to use classes in multiple places. Okay, so import is an important statement which we need to do at the beginning of the class. All right, so this is a basic information about what is Java package, how to create the sub packages, and how to refer those classes from the different packages using import command. We'll see a lot of things in the future. So there are two kinds of packages, user-defined packages and built-in packages. User-defined packages means we have created our own packages, right? So these are all user-defined packages, whatever we created. And there are some built-in packages also there. And whenever you want to refer some built-in classes, we must import those packages like java.io, java.sql. There are also some built-in packages are available. So in the coming sessions, I'll discuss all kinds of built-in packages. So there are two kinds of packages. User-defined packages, predefined or built-in packages. And java.util, java.sql, these are the examples of predefined packages. And when we import these classes, we can use it a number of methods. They're all predefined methods which are present inside these classes. So if you want to use those methods, we must import those packages and classes. Okay. So these are called predefined or built-in packages in Java. And user-defined packages, the user will define. So we can create our own packages. They are called user-defined packages. So this is the concept of packages in Java. All right, so this is a simple concept, just like a folder structure where we can keep all kinds of files. We can create sub packages and we can refer those package classes using import keyword. And there are two different types of packages, user-defined packages and predefined packages. That's it. All right, so now let us discuss in detail what is an access modifiers, what is the use of it. So there are four kinds of access modifiers we have in Java. One is public, default, protected, and private. So these are the four access modifiers we have. So what is the use of access modifiers? Basically, access modifiers are used to restrict the access levels of your variables and methods. Restricting the access levels of your variables and methods. Then we have to use certain kind of access modifier. So let us see what is the scope of these access modifiers and where we have to use and how we need to use them. So to understand this one, so first we need to understand one more important thing is, let me just open my whiteboard. So we need to understand the complete Java project structure. So what is project, what is a package, what is a class? The hierarchy we need to understand. So here, let us say I have a Java project. So let us say this is a complete project. This is your complete Java project. Okay, this is your complete Java project. So inside the project, we can create any number of packages, right? So here, this is one package. Let us say this is P1, one package. And this is another package called as a P2. And I have another package called as a P3. So I can have any number of packages. Inside the project, we can have multiple packages, P representing the package. Now, what packages contains? So packages contains multiple classes. So let's say C1, C2, and so on. And here also C4 and so on. And C5 and so on. So we can have any number of classes inside the package. Now, what C contains? So C contains multiple methods and variables. So C contains multiple methods. Let's say M1 and M2. M3 and M4 and so on. So every C classes contains a different number of methods and variables. So this is a hierarchy of project. Within the project we have a package. Within the package we have a class. Within the class we have a methods and variables. So this is a hierarchy. Now let us discuss about 4 types of access modifiers. Let's come to the lower level. First we'll see the private, then we go for protected, then we go for default, then we go for public, one by one. So first I'll talk about the private, and default comes here. Okay. So first let us see about the private. So when we need to use a private. So when I say a method or variable as a private, then what happens? So when I say a method as a private, right? So the private access modifier is accessible only within the class, only within the class. So inside the class, if I create a method or variable as a private, those variables and methods can be accessed only within the class. Okay, that's the restriction. We cannot access them outside of the class. Only within the class they have restricted. That's the first thing. Private access modifier can be accessed only within the class. Outside of the class we cannot access. Only within the class we can access. All right. So let me just show you one example. So let's go to Eclipse, and to demonstrate this, I'll just create another package. Go to package and I'll say access modifiers. Access modifiers. Finish. I'm just creating a package. So inside this, I will create a class. So a class name is something called a sample class. And then if you want to take main method, you can take main method. Let's finish. Okay, this is a class, right? So what I want to do is here I will create one more class. Let's say class A. So inside the class A, I will create a variable called integer A is equal to 100, or I'll also create one method called void m1, and this method will print the value of A, system.out.println. So println, I'll print the value of A. So this is another class I created. So now observe this. This is a class A, this is a sample class. Now if you want to access this method from class A, what I should do? I have to create an object for class A here. So let me create an object for class A is equal to new A, and now using this object I can access M1 method. This is perfectly right. So when I run this code, it will give you the output 100. But now what I want to do is I want to restrict these variables and methods. I don't want to allow anybody to access these from different classes. I don't want to allow anybody to access these things in different classes. Then what I can do is I can make them as a private. Simple. As soon as I make as a private, I cannot access them outside of the class. Immediately here it will start giving an error. So what is M1 is saying? The method M1 from the type A is not visible. It is not visible because M1 is a private method. M1 is a private method. So that's the reason it is not visible. M1 is a private method. And we can also try to access A. Let's say obj.a. I'm changing this value. But this is a normal variable, right? So we can change the value. So if we remove this private keyword again, so this is possible. So we can change this value. And now I'm printing the value of A. Now we'll get the 200. So because this is a normal variable, we can change the value anywhere else. perfectly right. But I don't want to allow anybody to access this variable or method. Then I can make it as a private. So when I say private, immediately here it will throw an error. So a.a is not visible. Similarly, when I say private for method, I cannot access here. So what we have understood based on this is private variables and private methods can be accessed only within the class. Outside of the class, we cannot access. Outside of the class, we cannot access. That is the first one. Private access modifier is accessible only within the class. Very, very limited access. Only within the class we can access. Outside of the class, we cannot access. That's a private keyword. Now, the next level is default. The next level is default keyword. So when I say default, if you don't specify any access modifier for a variable, that will be treated as a default. Okay. So for example, here itself, okay, I'll just comment these two. Okay, so if I don't specify any access modifier, that will be treated as a default. So for example, I'll remove this private here and here. Okay, if I don't specify anything, then the Java will consider as a default access modifier. But we don't have a specific keyword for default. Like private and public protected, we don't have specific keyword for default. If I don't specify any other access modifiers, that will be treated as a default. Okay, so when I say default, what is the access level? So when I say default, the access level is, if you don't use any access modifier, it is treated as a default by default. So if there are variable or method or default access modifier, can be accessible only within the package. Can be accessible only within the package. What does that mean is, if I create a variable or method as a default, can be accessible within the class and within the package. Within the package means all the classes which are available in the same package. All the classes which are available in the same package we can still access, but outside of the package we cannot access. So what does that mean is, if I see here, if I don't specify any access modifier, so that I am able to access here, because both are different classes, right? Both the classes are present in the same package. So we can access these methods and variables within the package. It can be different classes, but still we can access. But what is the difference between private and default? Private is very limited to the single class. Outside of the classes we cannot access. But if it is a default, we can also access outside of the class, but single package. Within the package only it is possible. Within the package only it is possible. So that is a default access modifier. So the default access modifier is accessible only within the package across multiple classes. Across multiple classes in the same package. In the same package. In the same package. So this is the importance of default. Now I'll little bit go higher. So now protected. So when we need to go for protected. So what happens when I use protected keyword? So protected access modifier is accessible within the package, outside of the package also. Within the package means all the classes within the package. Outside of the package also it is possible. What does it mean is, suppose there is a class in P1 package and methods and variables I have created as a protected, then those variables and methods can be used within the class, outside of the class in the same package, and outside of the package. Here also I can access. Outside means this is outside. So outside of the package also I can use, but the thing is, through inheritance only it is possible. I have to make this class as a parent class of this class. I want to make C1 as a parent class of C4. Then only it is possible to use those variables. Otherwise it cannot. That means it is not a direct access. So indirectly we are able to access using inheritance. So protected keyword can be used only within the inheritance. Okay, so that's it is saying. So the protected access modifier is accessible within the package and outside of the package, but through inheritance only it is possible. Only inheritance only it is possible. I'll implement this and show you. So currently we have this A class, right? A class we have. So I'll also comment these things. Now we have seen private and default. So now I'm talking about the protected. So let us create these two variables as a protected. Okay, or first of all, don't specify anything. So just let it be default. Okay, now I will create another package, a new package I'm creating. So let us say access modifier package is already there. So this is another package I'm going to create. Let us say this is access modifiers 2. Okay, this is another package called access modifier 2. So in the access modifier 2, I will create a new class and I'll say this is a sample 2 class and take this main method and finish it. Now observe this carefully. Sample, okay, so here the A class is present where in the access modifier package. Now where the sample 2 class is present under access modifiers 2 package. So both the classes are present in different packages, right? So now let us try to access this variable and method here because outside of the package. Okay, so how to access here? We have to create an object for the class. So A is my class. For this A class, I am creating object obj is equal to new A. Okay, now created an object. Now we can see it is giving an error. When I put cursor here, what it is saying, A cannot be resolved to a type. A cannot be resolved to a type. What does it mean is the sample 2 is present in different package. So it doesn't know about what is A, from where the A is coming from. So this package doesn't know about this. And not even it is showing import package. Not even it is showing import package, right? So this doesn't know about basically what is A is. So that's the reason it is giving an error. Now what I can do is I make, because these are the default. So default means it can be accessible only within the package. So that's the rule of default, right? Default means can be accessible only within the package. But now I'm trying to access them outside of the package. That's the reason it is giving an error. So what I will do now is I will make them as protected. And again make this variable method is also protected. I make them as a protected. But if you notice here, still it is not giving anything. Okay, no import package because the class we don't specify any access modifier. So class is also considered as a default. So default class cannot be used in another packages. So what we have to do is we have to make this class as a public, and then it is possible. So public means I think this class A is present in some other packages. So what I will do here is I will just separate this class A as a separate file. Okay, under same access modifiers package, I will create A class and I'll make it as a public class. Okay, so inside this class I will write this one. I'll remove from here, I'll put it here, and then comment this complete class. So we should not have a duplicate classes in a same package. So we have to just comment this. So now I have commented everything. Okay, commented. Only sample class is there. So fine. So close this sample class. For now, we don't require the sample. We already seen that. Okay, so now I have a class A which is present inside the access modifiers and which contains the two things. One is variable is protected and then one is also protected. Now let us come to the sample 2 which is present under access modifier 2 package. So I want to access these variables and method from different class which is present in under different package. Okay, so how we can access? So I can just create an object new A. Now we can put the cursor here. It will show you import package. Import, because by default sample 2 doesn't know about this A class. So now we need to import this. Import A access modifiers. So once you have imported this A class from access modifiers package, then you create an object and then I can access everything from this object. But still, if you see here, obj dot, so obj dot, when I say dot, it is not giving any variable or method. So if you're trying to access the value of A here, if you're trying to change some value of A, it will not allow you because it doesn't know about A. The field A dot A is not visible. Not visible because these two are not a public, they are protected. But what I said here is protected access modifier is accessible within the package and outside of the package. I'm saying outside of the package is also accessible. But here we are not able to access. Why? Because we haven't used inheritance so far. So we have to use inheritance and then we can access. So here obj.a we cannot change. And suppose obj.m1 is also not able to call. These two are giving an errors. But what can access this? We have to make this A as a parent class of this sample2 class. Okay. So how we can make it as a parent? By using extends a keyword. Extends A. So now A becomes a parent class of sample2. Now whatever things are A belongs to A, again they are belongs to class sample2 also. Right? So when I say these things are belongs to sample2, we can directly use them. So we can directly use them. We don't need to create any object. If you still want to access them, we have to create an object for sample2 class, not for A. So we have to create an object for sample2 class, not for A. Because A is already extended into sample2. Sample2 contains everything from class A. So then we can access this variable. So what we have understood here is, if the variables and methods are protected, we can access them in outside of the package, but only through inheritance only it is possible. So when I run this code, it will give you an output. This is an indirect access. It is not a direct access. So direct means we should not use any inheritance concept here. So directly through object, if I create an object for A, we should be able to access those variables and methods directly without having any inheritance. But here, when I create an object for A, I am still not able to access them because we haven't used any inheritance concept. So when I say a protected access modifier is accessible within the package, it can be accessible directly. But if I try to access outside of the package through inheritance only, it is possible. Okay, so far what I have seen. So within the class, if I say private, only within the class we can access. If I don't specify anything, will be considered as a default. So default access modifier can be accessed within the class, within all the classes, within the same single package. So when I say variable and method as a protected, we can also access outside of the package, but through inheritance it is possible. And the fourth level is a public. So when I say variable and method is a public, then those variables and methods can be accessed within the class, within the package, outside of the package directly without having inheritance concept. So public is a higher modifier. We can access everywhere. Now what I will do is I will make them as public. So instead of protected, again in the class A, I will make them as public. Apply a public access modifier here. Public and public. Okay. Now here we don't require this one. So I'll just comment this one. I committed entire class. Now I don't use any inheritance. So I'll just remove the class A. So here I can directly create an object for A. That's it. Now this is a direct access. Okay, this is a direct access. This is the direct access. So without inheritance. So now we can directly create an object for A, and through that object I'm able to access A variable and M1 method. So this is a direct access. Okay. So these are all called access modifiers. So what is the use of access modifiers? To restrict the access levels of methods and variables. So if I say private can be accessible only within the class. If I say default, within the package only we can access. When I say protected, outside of the package is also possible, but through inheritance it is possible. When I say public, it can be accessible anywhere within the class, within the package, outside of the package, throughout your project you can access anywhere. So that is all about public access modifier. Okay, so these are all 4 access modifiers. So public, we don't have any restrictions. Everywhere we can access those variables and methods when I say public. So these are all access modifier concept. So let me just summarize all 4 types of access modifier, then you will get a clarity on this. Just a moment. Okay, so this is just overall summary of access modifier. So far we discussed. So when I say private access modifier, it can be within the class we can access, within the package, within the outside of the package, nowhere else except within the class. We nowhere else we cannot access private access modifier. Then default is not a keyword. If I don't specify private, protector, public, that will be treated as a default. So within the class we can access, within a package also we can access, but outside of the packages we cannot access. And this is little higher than private, and protector is little more higher than default. So we can access within the class, we can access within the package, and we can access outside of the package, but subclass means inheritance only it is possible, but outside of the package directly it is not possible. But when I say public, out within the class possible, within the package is possible, outside of the package through inheritance is possible, and without inheritance also possible. This is a direct access. So this is a summary of access modifiers. Okay. So we have discussed all about access modifiers and everything. So with this, we have done the session. So if you have any queries now, you can ask me. So I'll just give 2 assignments today. Come to the assignments. Okay, just hold on. So come to the assignments. So these are all 2 assignments I'm giving. Assignments. So the first assignment is write a program to demonstrate the interface. Just create one interface called A, which contains 2 variables and a method called abstract method, and create one more class B, which will implement these methods which are defined in the interface. Okay, and do sum of A plus B in the class B. Okay, so the method is sum. It will take 2 parameters, integer A comma integer B. Define 2 parameters. Okay, or else don't require, because these variables we already defined in the interface, A comma B, and add a few values because this is a final variable, so we should add some values. So the sum method will perform addition of these 2 values. So create one class A where you need to redefine or implement this sum method, which will perform sum of A plus B. That's one assignment. And the next one is write a program for multiple inheritance by using interface. So I already told you in this class, so same thing, same concept you have to implement here. So interface A contains 2 variables and there is an abstract method called as add. Interface B is another interface which contains 2 variables. It will perform multiplication operation. So first let us create these 2 interfaces and then create one more class called as a calculation, and this class should implement these 2 interfaces. And this is multiple inheritance concept. So we can implement multiple interfaces using one class, right? So this class implements method from A as well as B. What are those methods? Add and multiplication. So these 2 methods we have to implement using a class. Okay. So this is another assignment you guys can try today yourself. Okay. So that's all for today, guys. So I'm done. So if you have any queries, now you can ask me. I'll stop the session. All right. So today we'll see one more topic from Java, that is exception handling. So exception handling, this is one of the important feature from Java. And first let us see what is an exception, and then we'll understand what is the importance of exception and what is exception handling. All the topics. So normally when you start writing your code, right, so sometimes you may see some kind of errors. So error is different and exception is different. Okay, exception is not exactly an error. So errors are 2 types, like syntax errors, logical errors, and exception is different than error. So first let us see what is an error, syntax error, logical error, and how the exception is different than its error. And if I get an exception, what is an impact of that exception on our program. So that we will see first. So normally there are 2 kinds of errors in programming. Any kind of language you can take, there are 2 kinds of errors. The first one is syntax errors. And syntax errors means the user mistakes. Syntax errors means the user mistakes. So for example, if I miss some semicolon, or if I miss some double quotations, something like this, if you miss something in the code itself, there's a syntax errors. So in the syntax errors, if you have the program, you cannot compile and you cannot execute your program until unless you modify the syntax or you fix the syntax. And syntax errors are the errors which are happening in the programming itself. So if I don't follow the rules from the programming perspective, then you will get a syntax errors. So simple example is if I say simple system.out.println, okay, this is the command. If I don't put some semicolon like this at the end of the line, it will throw some error. So this is an example of syntax error. So user can easily fix this error. So if you have syntax errors, the program itself will show you the with red color underline. So it will have some syntax error, something like this. So this will call as syntax errors. If you have a syntax error, you cannot compile and execute your program. And there is another kind of error, that is logical error. So logical error means it is also a kind of error, but if you have some logical error in your program, you will be able to compile and execute it. But at the runtime, you will get incorrect output. Suppose when I say it, I have created one program addition of two numbers. So when I provide two numbers, like say 2, 3, it should produce 5 as an output. Okay, this is what I'm expecting. Suppose instead of 5, it is providing some different number like a negative number or some different invalid output like this, right? So these are all outputs is producing, but they are incorrect. They're not correct. So these are called logical errors. So logical errors means also a programming error, but you will able to compile your program and execute your program. But at the runtime, you will see incorrect output. That's not accurate one. So this is also called as a logical error. So these two kinds of errors are in our hand. Like a developer has to fix it. Suppose if you are getting some incorrect outputs, then there is some incorrect logic is written inside the program, and the developer has to find out where he has made some kind of mistake, and then he has to rectify it. Okay, so these two are comes under the errors, syntax errors and logical errors. But when you come to the exception, is completely different. So exceptions occur at the runtime based on the user input. Okay, so exceptions are different. Exception occur at runtime based on user input. Suppose as a user I have provided some invalid input at the time of at the runtime, so that invalid input is causing some kind of exception. So when I get an exception in the middle of the program, the impact of that exception is I immediately terminate from the program. So I cannot continue the rest of the lines of the code. So that is the main problem with the exception. So basically exception is not an exact error. So what is an exception? So let's see the definition here. So exception is an abnormal condition or it is an event which will terminate your program execution. So in Java, exception is an event that disturbs the normal flow of the program. So when I provide some invalid input at the runtime, so exception will occur. So because of that exception, what will happen is rest of the code in the program will not be executed. It will immediately terminate your program. Okay, that's the main behavior of exception. And exception is the event which will occur at the runtime. And the effect of the exception is our program will be terminated. If I say 100 lines of code I created and some 50th line or somewhere else in the middle of the program exception is occurred, as soon as exception is occurred, the rest of the lines will not be executed. The program is immediately terminated. So that is the main effect of exception. But what I want to do is, as a developer, even though the user is provided some invalid input, even though it is throwing some exception, I should be able to handle this. Okay, so to continue the rest of the code. So we should be able to handle that exception and to continue the rest of the code. That is called as exception handling. Okay, exception handling. So normally we have a code like this. Suppose if I created 10 or 20 lines of code like this, and some particular line is causing some exception, or user is provided some invalid input here, this statement will throw some exception. And if we throw some exception, rest of the lines will not be executed. Okay, but what we have to do as part of exception handling, we have to handle this exception and again go back and execute the rest of the lines. So this is a process of exception handling. And to do this, we have a different ways and we have a different blocks are available in Java. So by using them, we can handle this exception. All right. Now today we'll see how we can handle this exception and everything. So let me just show you some example of exception, very simple example of exception. And let's go to our project. And today I'll create a new package called new package day 10. Okay, so under day 10 package, I'm creating a new class called exception examples. Take main method, then finish it. So I'll just show you what is the impact of the exception. So the very, very important one. So here I'll just create the 2 lines code. So let us say system dot out dot println, and here I can say println. So here I will say some message. Let's say program is started. Okay, this is a simple message. And similarly, I'll create one more message. Program is progress. Okay, program is in progress. And then I will create one more message. 2 more messages. Program is completed and the program is exited. Okay, so now I have created 4 different statements here. Okay, so 4 different statements I have created here. Now what I will do is here I will write some statements. So normally when I execute this code, all the 4 lines are executed here. So we got the 4 lines output here. But now what I want to do is here I write one statement, right, which will causing the exception. So once we get that exception, then we'll see what's the impact of that exception. So here what I can do is I will just asking an input from the user, or you can also directly specify input here, but sometimes we will get the input from the user. But so far we haven't seen, right, how to take the input at the runtime. We can also accept an input from the user. So to accept the input from the user in Java, there is a special class called scanner class. Scanner is a class, and input and is equal to new scanner. So first we need to create an object for this particular thing. New scanner of system.in. Okay, this is a command we have to use. So what this command will do is this command. So scanner is a class from java.util we have to import. So scanner is a class we have to import from java.util package. So this is a predefined class which is present inside the predefined package. So this is the predefined package, java.util.scanner. So by using this particular input object, we can ask the input from the user at the runtime. So if you want to ask the input from the user, we can just say input dot next int, input dot next int. So this command will ask the input dot next int. So this is a command. So this particular command will ask the input from the user, and once the user is provided input, it will be stored in a variable called number. Okay, so this is a command scanner class object we have to use to take the input from the user. So as soon as the user is provided input at the runtime, that value will be stored inside the number variable. Okay, so now I'll do some step here. I'll just say A is equal to, I'll say number A is equal to 100, and I will divide this number by whatever number is provided by the user. Okay, I'm just dividing my existing number with the number which is sent by the user. So number is sent by the user, and A is another value I have defined here. Okay, now A divided by number, the result I will print here. System dot, let's say out